Ladies and gentlemen, let's take a look at this here this morning. So yesterday we had our test one. Now let's ask you guys, was that a difficult test, you think? Right? Was it stuff we talked about? Right. So the idea for you guys to understand that's important to know is that you always keep up with your what? Homework. Okay, you make that a priority. You do that every day as much as possible. And if you do those kind of things, you're going to be able to help yourself. And it's not just something that you do just in this class. I'll say you do this in all the classes that you guys take. This is the approach. It's very different than high school. I want to let you guys know that. High school was like, oh my God, that shouldn't even be legally allowed, right? But it is. Wrong button. Well, that's what it was like in high school for me. So you are kind of learning how to do things, I would say. You're learning how to approach a college environment, and that's a positive thing. Now, again, some people, they're learning, and I understand that. You know, this is about as big as it gets. But anyway, so we did some work yesterday, a test, and you probably get that back if you're lucky this week, but certainly on Monday. Okay, so I just want to let you guys know that's what's going on, and all right, so okay, so what we're going to work on today here, if I can find it, we're going to work on graphing trigonometric functions. Now, I got out Microsoft Excel for you to share with you. These x values, this is an important detail. These are in radians. Okay, and this is actually going to give you a corresponding y value. Y is sine x. So this is in radian measures. So we're going to go here and say, okay, equals sine parentheses, that cell. We're going to close it. Now, ladies and gentlemen, these are sine values. These are in radian measure. And I want to try to take a look at all these numbers here. I went all the way down to about 6.4. And there you guys go. So this is going to be, if we color coordinate that, x versus sine x are really x versus y. Okay? And the x values are in radian measures. Now you're going to see corresponding y values. So if you take a look at this and you go, oh, these are the corresponding y values. Now what I'm going to do here is I'm going to try to plot these. Okay, I'm going to take all these points in radian measure. What's the value of pi, by the way, in radian measure? Do you guys know? It's about 3.14, right? So you say 3.1. So in other words, if you went up to 6.2, that would probably be pretty good. But I did, and I went over. But what I'm going to try to do, see if you guys can see this here, if I could even remember. And by the way, this is kind of very small for me. I don't know. Where is it at? 170? Let's try to do 200. Okay. So I have to now go to, is it draw? No. Insert, we're going to insert a, what is this? Scatter plot. Okay. Now, what you guys see here is what kind of curve, by the way. You guys see this here? This is known as the what? The sine curve. Okay, here's your sine curve, and this is only for what we call one cycle. You say, well, what do you mean one cycle? Well, one cycle along the what? Real number line. So I'm going to go over here and give you the details. Go to the iPad now. Okay, so what I have here is the graph of sine, and we let that be a y coordinate value. And then your x values were what again? What do we say about the x values? These are what? Radians. Okay? So those are in radians. And radians is another way of saying a real number. Okay? Now, the picture that we drew, here's some facts here. Here's a fact. The picture that we drew for this x is between 0 and 2 pi. This is known here as 1 full cycle. Okay? This is one cycle only of sine. From 0 to 2 pi. So if I go back here and you go, oh, okay, this is the sine curve. You guys know it starts at the origin. And what's the maximum value of sine, by the way? You see it's 1. Is that true? And then it goes back to the what? The x-axis? Where does it hit the x-axis, you guys think? Well, yeah, you say that's a little bit more than 3, Mr. Judge. Well, yeah, that's going to be really what? Pi, by the way. Okay? And then it goes all the way back to the x-axis. So what I want to share with you guys is this here. Even in Desmos doesn't give you just one cycle. What Desmos does is it gives you, let's find the sine function. And look at this here. It's in purple now in Desmos, and you guys can't see that, but now you can. So again, here's one full cycle, and this is the origin. This here is pi, and this here is what? 2 pi for one full cycle here, okay? So you want to know that one full cycle picture. And let me see if I can do something here. I'm going to try to mess everything up. Old man Judge. Yeah. Here it is, but learn something new every day, right? What do you guys think? Okay, so here's the sine curve. And remember this. What are these points called right here? These very special coordinates? What are these? Those are your x-intercepts, ladies and gentlemen. And they happen where x is 0, x is pi, and x is 2 pi. All right, so this is going to be some very important points here. Right? These are intercepts. Excuse me? Well, yeah, the definition of an intercept, if you guys remember, an intercept happens, and we should say an x-intercept will happen when x is 0 and y is any number. That's kind of the definition. X must be 0, but y could be anything, right? You say y is any real number. That's the definition really of an x-intercept. Okay? And I do have your classmates going, hey, Mr. Judge. So let's deal with that. All right. And then what do you guys notice that's special about this point? Because we have to talk about this point too. Right? If I said to you, what's so special about this location? Yeah, where does that happen? It has a It has a maximum value. What does that happen, ladies and gentlemen? Because because if you look at this distance here, if this whole distance is what? Pi, is that right? That makes this what? Pi over 2. Absolutely. Okay, and then the maximum value here for y, what's the maximum value for y going to be? 1, good. So, that has an address. The address there is x is pi over 2, y is 1. So this is going to be an important point as well. Okay, 0, pi over 2, pi, and then what do you guys notice about this location here? What's this address going to be here? Right? Think about this. I'm going to show you guys a little trick, okay? This distance here is what? 1 pi over 2. This is what? 2 pi over 2. Isn't 2 pi over 2 pi? And then what is this? 3 pi over 2. Okay, so you guys want to know that there. This is 3 pi over 2. And then that location is what? -1. So for this x value, 3 pi over 2, y value is -1. You're right. This is where you have a maximum value, and this is where you have a minimum value for your sine curve. And then to complete the cycle, remember we're at 3 pi over 2. This will be 4 pi over 2. What's 4 pi over 2? 2 pi. What's this address? Well, x is 0. Y is, sorry, not x is not 0. X is 2 pi, and y is what? 0. And I think I messed up on your definition. I messed up on your definition. X is 0, y is 0. This is for any x. I got it backwards for you guys. Well, the day wouldn't be complete without messing up once. But the point I want to make to you guys is this is one cycle. And what you guys want to know, this is 0 again, right? Zero, pi over 2, this is pi, 3 pi over 2, and 2 pi. Yes? X is any number, but y must be 0 for an x-intercept. So, ladies and gentlemen, so if I said to you, you are required to draw one cycle of sine here. Okay? And this is what you guys really want to get used to doing, drawing one cycle of sine. What you want to do is equally space things here. I go all the way out to a space out here, and you know what I call that? 2 pi. Okay, you guys with me on that? And then right in the middle, what do I call this? And I try to eyeball it in the middle. That's going to be halfway. That's pi. And so what you guys know already is this will be 0, this will be pi, and this will be what? 2 pi. Okay, so let me do something really quick here, ladies and gentlemen. Okay. Here we go. Go to video on how to locate and download the apps that we'll be using. And there we go. Anyway, okay. Where are we at here? Let's go back. So here's your cycle that you guys do, the intercepts. And then what do you think you guys do now? Right? What would you want to do now? Halfway. What is halfway? 1 pi over 2. Good. And then like I said before, if this is 1 pi over 2, this is 2 pi over 2. Is that right? Notice, isn't 2 pi over 2 pi? Halfway would be what? 3 pi over 2. And then another pi over 2, isn't that 4 pi over 2? And that reduces to 2 pi. You guys okay with that? Just nice arithmetic. And I'm not going to draw this to scale. Okay, I'm not going to draw this to scale. You say, what do you mean? Well, this is just kind of a sketch. Here's where 1 would be, and here's -1. And this is sketching this. So I'm going to start at this point here. I'm going to go to the maximum value. You guys okay with that? Then what I'm going to do? Yeah. Ooh, this is kind of slippery. I have to do this here. I'm back at the intercept. Then I'm going to get to this point here. And you get back up here. This, again, my curves aren't that nice. Okay. Okay. So again, this is what we call what? One cycle of sine. Yes, question. Why is it pi over 2? Because this is important. If this whole distance is what? Pi, is that right? What's half of pi? Pi over 2, exactly. Exactly, yes. Oh, you mean, well, you could, but I think they're trying to make reference to the fact that you have a what? A unit circle, right? And you say, well, where does this all come from? Yeah, like if I input this here, let me find my picture. I guess this one is a good one. Okay, so notice where's this point here? This is 0, 0, or 1, 0. Okay, that's an x value and a y value. And then this is 0, 1 over here, right? So this is quadrant 1, remember? Quadrant 1. That goes from 0 to 90 degrees as an angle. But what is the radian measure here? Right? For quadrant 1. This is from 0 to, what is that? That was pi over 2 in radians, is that right? And this was 0. So you say, oh, okay. So this here, when they say you're going to graph sine, that x value goes from 0 to pi over 2, and it's a real number, radian value. So you're defining this not in terms of degrees, although you can do degrees, 0 to 90 degrees. We define it in terms of radian measure, trying to get people to understand that that's a real numbered value. Or you could use a central angle. But this is what I'm saying here. This is where quadrant 1 would be, by the way. So if you guys didn't know that, I'm going to say here's quadrant 1. This is quadrant what? 2. You say, why is that quadrant 2? Because you're going from the angle of what? pi over 2 to pi, and you say, oh, but it was radian measure. Oh, we're going from 90 to what? Over here, 180 degrees. Right? Pi radians. So then you say, well, this is quadrant 2. What is this really? Quadrant 3. You say, why is it quadrant 3? Because you're going from pi in radian measure to 3 pi over 2. Okay, so this is going from pi to what? 3 pi over 2 in radian measure. So this is quadrant 3, really. And then quadrant 4 over here. And you say, well, why is that? Because you're going from what? 3 pi over 2 to 2 pi. This is that x value measured in radians. Your input here is x. And that's the last part from the unit circle here. Okay? So this is from your unit circle. So we're really plotting, in all honesty, all those terminal points. X versus y, where y is, by definition, sine x, right? So you're plotting that. That's all you're doing. Yes. What's that? Well, we're calling sine x the y coordinate because this is the xy plane. And these are all terminal points there, right? You got the x and y values. So you're just plotting what's called the output values here. And when you see that, this is the pattern that we get. In other words, you got a maximum value, you got a minimum value, and that's just by plotting points. And that's where the basic sine curve comes from, using your inputs of radian measure. Okay, radians are real number values. You say, but we use a symbol for that number, right? Pi is about 3.14. So those are radian measures there. And this is where the sine curve comes from. It's a very, very important curve. Okay, but now you say, well, what about this in general? We want to generalize this. You know, we define y equals, and I'll use the notation of your book, but a sine kx in general. Okay, now this is going to be, in all reality, a circle. This comes from a circle of any radius, by the way. Not a unit circle. We don't have to draw that circle. What we're going to learn, the graph of y equals a sine kx in general. Okay, so your book's going to have that definition here. And I always have to give you this. We're going to have to give you guys we're going to have to give you guys meanings of all these things. Like, for example, here, this a value here, by definition here, that constant a in front, we have the definition of what we call the what? Amplitude. Okay? So this is a for amplitude, but that's not the definition. The amplitude is the absolute value of a. Okay? So you take that, let me do this here. Let me erase this. The amplitude, absolute value of what? A. Nope. This means a can be negative, and we're going to see that. But the amplitude is always positive. You say, why is amplitude always positive? Absolute value of a. Okay? See what I'm saying? So we're going to see those things. So do you guys know what the amplitude actually is? Huh? Yeah, what's the amplitude? You go, oh my God, what's an amplitude? Really? This is here. If I go back in blue now, I'm going to try to erase some of these things from this curve. Okay, you see this here? You see this here? I'm going to change this to what? A and minus a. This here, this distance is the amplitude. It's the distance, you know, on the y-axis, if you want to think of it that way, from 0 to the largest value. Okay? And the smallest value, because this distance is the same. This is a and a. Okay, so here's your amplitude here. It's the distance from that x-axis point here, really to the largest value. That's where the max is, and then this is where the what? Min is. It's on the y-axis from 0 to the maximum value and the minimum value. That's why it's absolute value, because you want to describe distance as positive, right? So amplitude, if you want to write this down, this is a distance from 0 to, you can say the max and min along the y-axis. Okay, and then notice you got this thing here, k. Another definition of what we call the period. I'm going to paint that purple. So P for period, ladies and gentlemen, it's a formula. It's 2 pi divided by that k value. Okay. And maybe I want to focus, I'm going to call that k here. And that's what I colored purple here. So k is associated with the what? With the period. Okay? K is a constant number, and a k could be positive, k could be negative. K is just you're going to see it's related to the length of the interval. So we're going to find the period, an interval, one complete cycle here. And in the book, they define k originally as positive, but we're going to see what we can do to always make it positive. So this is going to be the period, ladies and gentlemen, is thought of to be, now I'm going to change the color for the period. Should we use pink? Can you guys see that there? Maybe not. Maybe we need another color. You say, what is period? You guys know what the period is? This is going to be the length of one cycle. And you go, the length of one cycle, yeah, go back to this curve here, right? You see that? That's the green value. It's the length of that one cycle. So, you know, in some ways we can look at it this way. You're finding the amplitude, okay? And you're finding that period. But you're going to do this now in general, because when k was 1, you say, we already seen when k is 1. When k is 1, you say, Mr. Judge, the length of one cycle is 2 pi, and I'll say yes. Because that's the graph we originally had. Is that right? 0 to what? 2 pi. And I give you one last definition, is the interval of one cycle. Okay? And maybe we'll color that, I don't know, orange, I guess, the interval of one cycle. So I'll call that I for interval. And that's actually going to be from 0 to, I'm going to say P, the period, which is the same as saying from 0 to what? If your period is 2 pi over k, this is what you guys have here. So this is called the interval of one cycle. Okay, so notice you need the period in order to find the interval of one what? Cycle. And then this is the information we're going to use to sketch a sine curve now. Okay, we're going to use all this information to sketch one sine curve. Now, this is just the curve here where the amplitude here was 1, okay? It's absolute value of 1, which is 1, and then the k value is also 1. Okay, and your interval of one cycle here goes from 0 to what? 2 pi, the period. The length there. 0 to 2 pi. So you're actually looking at, the very simplest sine curve that comes from the unit circle. But then you say, but they're going to give me something like this here. For example, say, what does this mean? You go 3 sine 2x. Okay? They're going to start off by saying to you, always determine the what? The amplitude, the what? Period, and the interval of one cycle. All right? So I'm going to highlight this. What do we call that number? It's not the amplitude, it's A. Is that right? What do we call this number? K. And yes, K is what again? K is positive. Okay? So how do I get the amplitude, ladies and gentlemen? It's the absolute value of A. You use your definition. Is that right? So what's the absolute value of 3? 3. Then your amplitude is what? 3. Okay, so far so good. What's the period? I'll say period is 2 pi divided by what? K in general. Okay. So this will be 2 pi divided by what number? Which is pi. Okay, now what's the interval of one cycle? I. What was that definition here? It goes from 0 to, what's the period? Pi. So in other words, this is where you start the sine curve in terms of an x value, and then this is where you what? End. It's your starting point and your what? Ending point. So all of this information is used to do what? To graph. So you can use all this to graph, ladies and gentlemen. So you say, what do you mean use this information to graph? Well, here's what we could do. We're going to go out now, and we're going to get our what? You're going to draw a horizontal axis, and, we try to draw it what? This way. I'm going to draw one cycle. So here's my x, and here's my what? Y-axis. Okay? So here's what I want to say to you guys, right? How do we start to do this? We're going to use that interval of one cycle. We start at 0 and we end where? At pi. Isn't that the period? So that's the length of one cycle. This is just a sketch. I'm going to put now pi, and I don't really put 0, but you can if you want. This is the period, and the interval of one cycle goes from 0 to what? To pi. Okay, you guys see this? This is that period value, p. You guys with me so far? Okay, and then now what was the amplitude here? 3. So we say, okay, I'm not going to draw it to scale. I'm going to say this is 3, and this is what? Minus 3. So I'm using the idea of the amplitude. So I really know where the largest value is and the smallest value is. You guys okay with that? Now, here's what I get to do. I get to use logic. This is how you guys get to deduce these things. If I go from 0 to pi, what's halfway? Just take pi, divide by 2. Isn't that right? Like if I was going to give you half of the money I have in my pocket, what am I doing? Say I had a $100 bill and I'm giving you half. What do I do with that 100? I divide by what? 2. See what I'm saying? So that's like the period divided by 2. Now, this is where people need to really learn arithmetic. And you go, Mr. Judge, arithmetic. You go, what are you talking about arithmetic? I never learned arithmetic until I took these courses. So isn't this halfway? That'll be half of this number. This number is, what is this number? This is pi over 2, is that right? And then I have to take what? Half of that. Now, this is kind of like the S portion of the course, in all honesty, right? What do you mean the S portion? Well, you're looking at a fraction. What you're going to have to know is the fraction of pi over 2 divided by 2. This is arithmetic, ladies and gentlemen. Right? You got the fraction pi over 2 divided by 2. How do we actually divide by a whole number, right? Multiply by the reciprocal. And what does this give you? This is pi over 4, ladies and gentlemen. So what you're going to need to do now, like on a test, is this arithmetic. You're going to need to know that that is going to measure pi over 4. You guys okay with that? So that shortest distance for the sine curve, I need to know, hey, sine goes from 0 to what? Pi over 4, really. And then it comes back down to what? To pi over 2. Good. And then it goes, what's halfway again? Yes. And it's going to get down to that negative 3. But I need to know what that is. Yeah, see? And then I go back over here to pi, but I don't even know what that number is. You guys know how I deduce that number, ladies and gentlemen? I do it by counting. I'm going to share with you. It's quick and easy. And this is the process of graphing. You guys want to learn how to graph this. So it's quick and easy. Let me ask you this question here. What's this distance? Pi over 4. What if I add another pi over 4? You know, does that make it? That makes it now 2 pi over what? Doesn't that reduce to pi over 2? And you go, yes. So I'm taking multiples. I'm saying 1 pi over 4, 2 pi over 4. What's this? 3 pi over 4. And there it is. So we're actually learning how to do what? Count even. And that's the physical nature of the what? Of the graph. What is this the graph of? I sometimes label it, ladies and gentlemen. I'm going to say y equals, what was that? 3 sine 2x. That's the graph of 3 sine 2x. And all it is learning this what? Process. Yes. What do you mean by the coordinates? The y values, well, first of all, you have y values here that are 1, 2, 3, 4. You have 5 y values. You're not finding all the other y values. You're sketching the graph. And this, again, is the maximum value. So you have to know, how do you even read a graph? Right? This location, x is pi over 4. What is y? 3. This location, x is 3 pi over 4. What is y? Negative 3. And then you have the intercept points. You say, how do I get that? X is 0, y is 0. X is 0, y is pi over 2. And then x is 0, y is pi. So you're going to need to know really these 5 points in all honesty. You don't need to know all the others. Right? No, I'm not awake again? All right. I got it backwards again. Pi over 2. X is pi over 2, y is 0. Let me get that. And then x is pi. Thank you so much. I got to wake up. So you got to know really those 5 coordinate points in all honesty, not all the others. And really, you just need to know how to read this. And it's going to be that simple. This is kind of what they're going to ask you. They're going to say, hey, give me the amplitude, give me the what, period, give me the interval 1 cycle, and sketch the curve. And then when on a test, you know what I look for in a test? I look for, do they have the right 5 coordinates kind of, and do they sketch the curve, you know? It's kind of graded on a matrix. You want to know, you don't want to draw a triangle when it's a sine curve. Some people draw triangles, and you're like, I don't know what planet that person's on, right? You draw a triangle, this was a sine curve. So part of this for you is going to be this. If I go back to my website, right, and I say, okay, where's my website here? You know, I go back to your course, and actually all the other courses too. See if I have it. Yeah, like if I go to, let's say Calculus 1, right? Go home. You know, what I share on the first day with Calculus 1 students is, what is that first link? Curves every B-STEM student should know. And so if you click on this, these are all the curves you guys want to know if you're going to take a calculus course, because you're going to be using them throughout the calculus sequence. And so I have students memorize how they look, because these are all curves you've studied already, all the way up to Calculus 1. And then at the very end, you start to see, oh, you got to say, Mr. Judge, do I need to know what a sine curve looks like? And what do I say? Yes. Hey, what about a cosine curve? Do I need to know what that is? Yes. What about tangent, cotangent, secant, cosecant? Do I need to know all those curves? What do you guys think? Yes, this is why we go over the graphing portion now and look at the details. You know, so it all fits. I hate to say it, it all fits to what you're doing in the grand scheme of things. Okay, so you're first learning about the sine curve and these important points, and you know, you're just starting from the basics there, right? Now, I want to give you guys a note about a few things. Okay? Well, the sine curve for the y values are between what? -1 and +1. Is that right? So you go, what do you mean? That's the first graph we looked at. These are all y coordinate values. This is AKA, so if you ever see that, that's the absolute value of sine being less than or equal to 1. So that's one fact I want you guys to know. The second fact in general, if you say, what about this curve here, right? Sine of kx with an a value. Well, that's going to be less than or equal to a, which is minus a less than or equal to a sine kx less than or equal to a. These, again, are the y values. So it's saying that the y values are between -a and +a. And that's all that I'm writing here for you guys in this picture, okay? They're saying, hey, are all the y values between these -3 and +3? Yes. Do you guys happen to know what you're really looking at in some ways? Isn't that the range? So if you're going to take Math 260, you learn what's known as the range. And that's the set of all y values. Anybody here taking 260? Right? They talk about domain and range, input values, output values. Yeah. So that's kind of looking at the range if you guys want to see, you know, that curve is between negative a, positive a. The output value is the y values. It's the range. Sine in general, if it's no k value there, is between negative 1 and positive 1. Okay, that's really your range in that course. Let's give you guys another example here, right? You say, okay, what if they gave me y equals negative 2 now, sine of maybe 3x. They want to know the amplitude. Well, what is a now? A is going to be what? Negative 2, is that right? And what's your k value? Positive 3. So I have to take the absolute value of negative 2, which is, what is that number? Positive 2. Here's my what? There's my amplitude. And then the period is going to be 2 pi divided by what? You say, is that k? Well, k here is what? 3. Okay. And then what's the interval of one cycle? You start at 0, you end at 2 pi over what? Over 3. So you have all the physical information that's used to do what? To graph. To sketch the curve. Okay. All right. So now if I said to you, okay, what are we going to do here? Well, we're going to get out the framework. If you want, always start with the framework here. And you go, okay. And this is just a sketch. So here's what we say we can do. Always draw. Remember, the purpose of getting the period is for what? Because you know the length of one full what? Cycle. Okay? That's the purpose of getting this period here. That's where that goes. You start at 0, you end at what? 2 pi over 3. The length of one cycle, 2 pi over 3. All right, you guys okay with that? All right, now, here's the deal. What am I going to put here? It's not to scale, I understand that. But what are we going to put there? Well, what was the amplitude? 2. So this is 2, and this is what? Negative 2. Okay? You guys see why we had to find that amplitude value? This would be 2. What's this? Negative 2. You're finding, again, the range of the curve. So the range is between negative 2 and positive 2. Okay, you guys okay with that? Maybe we want to write that down. So that, you know, if this comes up, range, instead of all y values, that's between negative 2 and what? Positive 2 for this function, y equals, you know, what it is. So this is kind of the range so you guys know that you're finding there. That's how the amplitude works here. Okay, that's a range value. So anybody have any questions on this so far, right? What do you guys think? Do you have any questions on that? Let's see where these guys are at. Yeah, good morning to you guys out here. I apologize for the technical difficulties we had this morning here. It all started with the wireless not working. I wonder if it's working now. I hope it is. Good morning. All right. Interval of one cycle. We got all that information they're going to ask us. Good. Now, we're going to have to do, this for some people is the hard part. And the hard part's the arithmetic. So I'm going to try to find halfway, right? Let me see if I can find halfway. This is 2 pi over 3 divided by what? 2. Okay, you guys okay with that? So this is the S portion of the course. What does this equal? Right? Isn't this 2 pi over 3 divided by 2? So it's 2 pi over 3 times 1/2. 2's cancel. What is the length here? What is this value? Pi over what? 3. And then what about this over here? What's half now of pi over 3? Divide by what? 2. So this is where you're going to have your what? Arithmetic. Pi over what? 6. Okay? Now, some people get so good at this because they've practiced it, they do it in their head practically, you know. I would suggest you write it down the way I do. Notice I'm not just saying, hey, that's pi over 6. You guys see what I'm saying? I'm going through the work with it. This is your arithmetic. You got to know how to take a fraction and divide by whole numbers. You got to know how to simplify fractions. And then you got to know how to count. You go, what do you mean how to count? What's this distance here? What's that distance? 1 pi over 6. And then what's this? 2 pi over 6. Do you guys know that's going to be pi over 3? And then what's another halfway? 3 pi over 6. Hey, what does that reduce to? Pi over 2, ladies and gentlemen. See that there? And this is going to be, right, 3 pi over 6. This is 4 pi over 6. You know what 4 pi over 6 reduces to? You don't have to do this, but it's already there, 2 pi over 3. Isn't that a nice approach to what you're doing? You want to label and sketch these points because these are also additional points where you have the maximum and minimum value. All right. That's the arithmetic. So, ladies and gentlemen, you know, that's kind of like you say, is that the S portion? How we go through all this stuff? Well, sort of, you know. But anyway, here's the deal. You have one other issue. What do you guys notice about this? This is a big, important detail. What's the effect? Do you guys know this? Yeah. What's the effect of putting a negative number in front of any function? This is going to reflect. Anytime you have a negative, you're going to reflect about the what? X-axis. What is reflection? It's like if you put a mirror on the x-axis. And then what are you really reflecting? You know what you're really reflecting? If you had y is 2 sine 3x, the positive portion, because now you're making every coordinate opposite. Every y value is opposite now. So what I do, here's what I do. I do this. I know you're going to say, the sine would look like this. Is that true? That's the positive sine curve in blue. Y is 2 sine 3x in blue. But that's not the curve. What do you have to graph here? -2. So I'm going to place my mirror across the x-axis, and I have to reflect every point about that x-axis. What does that look like? You guys know what that looks like, ladies and gentlemen? Instead of going up, it's going to be opposite. This point is really down here. So it goes below. And I want to try to draw a nice curve. So, and then this comes back up. Isn't that reflecting It's not a perfect reflection. So every point here gets what? Reflected. It's on the other side of the x-axis. Even the points down here, they're what? Reflected. And the points down here are reflected. That's the real curve in black that they're asking for. But I always do the blue curve. It's kind of thought of as the ghost curve. I call that my ghost curve. Because it's not really there, but it's used to reflect. So this is the effect of a negative sign in front of any what? Curve, ladies and gentlemen. Okay, you guys okay with that? Easy breezy? All right, let's try another one. What do you guys think? Y equals, I'm going to say here, 4 sine of negative x over 2. Let me, yeah, of a minus x over 2. Okay. Now, remember when they said to you earlier here, because I know you can find the amplitude pretty simple, right? What's your amplitude again going to be? Yeah, you take the absolute value of 4, and that gives you 4. And then what's your period going to be? You go, but Mr. Judge, they told me K is going to be always what? Positive here. Is that right? Anybody know what's going on here? If you ever see negative anything, you know that's negative 1 times that thing? Okay. But also, what do you think you're going to use? What did you get tested on yesterday? Even in odd functions. So what can I do with the negative inside there? I can pull it out. Is that true? Because sine is what? Odd. That's the point. Remember I told you, you're learning that stuff for a reason. So the amplitude still is going to be what? 4. But now, could you tell me, what is your K value? Don't tell me K is 2. What is K? K is the number, this is 1/2 times what? X. So what is K? 1/2. All right, you guys okay with that? The K value is 1/2. So when you compute the period, what's the formula for the period? 2 pi divided by K, or 2 pi divided by 1/2. Again, what is this? 2 pi divided by 1/2, which is 2 pi what? Times 2, better known as 4 pi. This here is your what? This is your period, ladies and gentlemen. So that the interval of one cycle becomes 0 to what? 4 pi. Okay? 0 to 4 pi. So in other words, you are doing some arithmetic and you're reading the graph, and that's what you're here to learn how to do. Read and do some arithmetic. Okay? So just remember, K can be a fraction. K is positive. Notice K is positive because we use odd and even ideas here. All right, for sine. This is part of why you learned it. Remember I said, this has to do with physical attributes for graphs, right? Well, that's what we're starting to see. The relationship here with those negative values, but okay. Now, ladies and gentlemen, we're going to sketch the curve again. Okay? Where do you start? You start at what? 0. Where do you end? 4 pi. So you know what I do? 4 pi. This is just a what? Sketch. Wrong, buddy. This is just a sketch, not to scale. What do I do next, ladies and gentlemen? And look at that line. That line doesn't even look straight. Look at that. You would never guess my parents are what? Artists. Huh? What do artists do? Everything. Draw, paint, you name it. Work with crafts. What does art do? With jobs? Artists can do a little bit of everything, or a lot of everything. I mean, my father did back when I was a kid. Anybody, what's the program Nova? PBS, Nova on PBS, I think. He did the first Nova poster. Very first one. Daniel Judge Sr. Anyway, do you guys like art? I think we all like art, but I would not try to make a living at art. Okay? Word of advice. Why do you think, my parents, my brother's an engineer. I'm a mathematician. Why do you think we actually did those things? Because he wanted to eat. Artists don't necessarily what? Eat. Okay, and that was actually true for my parents too. So anyway, who cares? All I know is, what's half of 4 pi? How do you get it? You say, Mr. Judge, I do not know. Well, take that 4 pi, divide by 2, simplify. What do you get? 2 pi. Is that right? So you get better, better, and better with this process. What's half of 2 pi? You say, I don't know. Well, take 2 pi divided by 2. What do you get? You get pi. You guys see what I'm saying? Because I wanted to learn how. I not wanted to learn. I wanted to what? I wanted to eat. Isn't that too real? I hate to say it. And then what do I do to get this last important point, right? You remember the counting? 1 pi, 2 pi. This will be 3 pi. Good job. And then the last one's going to be 4 pi. That makes a lot of sense. You guys okay with that? What's the amplitude again? 4. So you say, why is that important? Because I'm going to have to write 4 here, minus 4. So what does that mean about the range? Your range is between negative what? 4 and positive 4. And we put range in set notation. That's why you find the highest value and the lowest value. Now, is this a negative in front of my sign? Uh-oh. You see what I'm saying? Why is that little bit piece of information important? Because what does that mean? Does that mean it means I have to draw the ghost curve? The ghost curve. That's for a positive sign, but what do I have? Negative sign. So I can now get rid of the what? The ghost. Notice this important detail. This point and this point. X is pi. Y is negative 4. I think I'm waking up. X is 3 pi. Y is positive 4. This is where you have a min. And this is where you have a what? Max. So if I went to Desmos, just to kind of graph that version, y equals minus sine again. You guys see what I'm saying? You see what just happened? Y equals minus sine. Okay, I'm going to get rid of the purple. Get rid of the ghost curve. Doesn't it start by going to the minimum instead? The answer is yes. So it is reflected about the what? the x and y axis. And then if I just wanted to say to you guys, look at that k value, right? Y equals sine here of, for example, 2x y equals sine of negative 3x, you know. Your sine, right? Sine of 2x made one full cycle shorter. Is that right? And then you have minus 3x. So it should be shorter and inverted in blue, and it is, you know. But, you know, just kind of sharing with you guys here what we're doing by hand, what we're trying to learn. We're trying to learn these very important points. What's this location? These are what? X-intercepts. It happens when x is 0, y is 0. It happens when x is 2 pi and y will be 0. X is 4 pi and y will be 0. So you have these extremely important points we're really trying to be cognizant, aware of. These are some details that we care about for the sine curve. Okay? And then I'm going to say to you guys, guess what? Similarly, you have y as cosine. So we can say the same kind of things for cosine. So if you go now to back to where we're at here with Microsoft Excel, let's find this stuff here. Gosh. I'm going to do the same with cosine, right? So remember how I started this off. I said, okay, equals cosine. These values of x are radian measured values. We're looking at it as input-output. When x is 0, what's cosine? Starts at 1. That's interesting. So these are all the y values for cosine. Now I want to put them on a scatter plot. So I'm going to highlight them. I think I could do it that way. Insert a scatter plot, and sure enough, ladies and gentlemen, you're looking at the graph of what? The cosine curve. Notice it starts at the highest point, doesn't it? And then it ends at the highest point, but in the middle, you're at the lowest point. Okay, you guys okay with that? And those are radian measures, real number values down there. We don't put 1, 2, 3. We put the symbolic version of it, pi's, multiples of pi's. But you're looking at cosine now. So, okay, the basic cosine curve of one cycle, this is only one cycle. To share with you again, that one cycle, that one picture, just as a sketch. This is from 0 to what? 0 to 2 pi. Oh, you guys can't see that. Let me put that where you can see it. Okay. This is the length of one whole cycle. We do the same thing. Half of 2 pi is what? Pi. Half of pi. Pi over 2. And then I do the multiples. 1 pi over 2. 2 pi over 2. And what? 3 pi over 2. Okay? And then the range is between what? -1 and +1. That's not to scale. So I'm going to get my range again. Now, where does it start again? Starts here. At x is 0, y is 1. It actually ends the same place. Guys, notice that? X now is not 0. X is what? 2 pi, y is 1. So if I go back to Excel, you go, oh yeah, I see what you're saying. It starts and ends at the same point. Yes. And then what do you guys notice? Where's the intercept? You know, where are the x-intercepts? Pi over 2 and what else? 3 pi over 2. And then it hits the minimum where? At x is pi. -1. So if I even went back to Excel, no, that's not Excel, right? It's around 3.14 because that's pi. It's at the minimum -1, and the intercepts are in the middle there. So now I'm free to sketch. Okay, I'm going to go down to my first x-intercept, get to the lowest value, back to an x-intercept, highest value. So you're going to have your what? Maximum value, maximum, 2 maximums, and a what? Minimum. The intercepts are at pi over 2, y is 0, 3 pi over 2, y is 0. These are your intercepts in red. Okay, so there's your fundamental what? Your cosine curve based on the unit circle. What time to get out of here? 35? Yeah. So what do you think the general version is? I guess I just have time to write down the general version. Right? You got y is a cosine kx. What do they say about k again? K is positive. And of course, you have the amplitude as the absolute value of a, period, 2 pi over k. The interval of one cycle is the same, 0 to what? 2 pi. So I just wanted to leave you with the general version for cosine as well. And ladies and gentlemen, I'm going to say that this is now going to be starting to work with questions in our book. Let me double check. Okay. And I'm going to go back over here. Let's go back to Canvas or the website. This is going to be, now we're going to add another assignment called what? What do you think this one's going to be called? Outstanding. Homework 2. Good. And then when's our next test? Anybody know? If I go back to the schedule. Oh, what is this? October 17th, right? So when I say due date, what should it be? October 17th. Is that the day of my dad's birthday? It's, oh, no. Come on. Edit. So this is going to be from the book. 5.3, 1 to 40. Oh, we're going to still do some more. We're not done. We forgot to put the points. This is going to be what? 20 points. You submit this online as what kind of file upload? PDF. And that's going to be when it's due. Well, it's going to be due at what time? 7. What time do we start class? 7:15. Now, don't turn this in if you get done today. Why is that? There's going to be more. Remember that? So you guys are starting to understand how this all works. Okay? Because sometimes people don't understand how it works yet. Oh, and we did this. This should be AM. Save and publish. So we're getting started on graphing. So ladies and gentlemen, look those over. When do you think you guys want to get started with this stuff? ASAP. Hopefully what? Hopefully today. All right. You guys okay with that? All right, we'll see you guys later. Take care. All right, you guys okay with that? Now, yeah, I drew, this is your basic cosine curve. Okay, now remember the range here. Let's do some notes here. Remember, what is the definition of the range? If I move this down here, those of you guys that are, you're going to need to know this in math, and it's always good to know. What's the range, right? It's a set of y values such that what? Right? You guys remember what a range is? Let me give you a point on the curve. I don't know what color to pick. Maybe pink. You have an x coordinate and you have a y coordinate. Is that right? The range is a set of output values. Okay, so it's actually, if you guys want to really think about it, draw a horizontal line. Okay? And everywhere you touch the curve, those particular locations on the y-axis, like here, you go, hey, I touched the curve there, right? That's going to give you your range values. Okay, like a horizontal line gives you domain values, just so you guys know. So here, the range is going to be between what? What numbers here? I really shaded it in blue for you guys. It's a set of all what? For y values between -1 and what? +1. So this is kind of the range, so you guys know what we're talking about. Okay. What's that? Well, the range can be at 0, but you're writing an interval here. If we cross that, do we touch the curve? We do. Here, right? Don't we touch the curve? We do. So it's just a set of y values. Well, horizontal, and we're going to talk more about that little detail here. Note the horizontal is the domain. Okay, so if you guys said, oh, I'm going to change this color here for us. I mean, it's, you know, so you guys can see that. Horizontally or vertically now, if we said, okay, what about vertical? Wherever you touch the curve, if you, for any x value, okay, what I'm doing here. If you notice, that's the domain. So I'm just going to say here, your domain, ladies and gentlemen, it's a restricted domain. It's a set of all x such that x is between what numbers? 0 and 2 pi, because we're only looking at one cycle, right? there's only one cycle. So you say, well, what do you mean these x values? Yeah, all these x values on the x-axis from 0 to 2 pi. Okay? So I know I'm butchering the picture on that, but this is a very simple way to determine domain and range, but yet you do need notation knowledge, and this is set notation, okay? So we've been focusing on one cycle. So we've done what's called a restricted domain, only one cycle, because we know that the domain for cosine is really all real numbers. And you go, what do you mean it's really all real numbers? Yeah, if we go to Desmos, we say, okay, Desmos, instead of the sine curves, hey, draw me a cosine curve, right? Now, what you're seeing here is if we drew those lines, if you said x here equals 5, and notice what I can do with this here. Can we do that here? I think we could move it around, can't we? Yeah. See where I hit? You see where I hit these x-axis? I hit it where? I hit the curve. The corresponding x values where you hit the curve is everywhere. Is that true? But you can restrict the domain as well for cosine, one cycle. And I think I have to do something here. Let me double check. It's always good to know. Let's say Desmos, restrict domain. So you guys notice the difference? Because this is going to be a big part of the course. I think you have to use, you use the curly brackets. So I might go here and say, okay, where are you at, curly brackets? And I can hit 0, less than or equal to x, less than or equal to 2. And I want to put pi. I think I have to spell it. There we go. Okay? So if you guys can see again, this is only one cycle. And you say, where do I start to hit the curve and the x-axis? From 0 to what? 2 pi. Okay, so it's a restricted, this is only one cycle. We can't draw the cosine curve for all real numbers at all because you would die. It goes on forever. You guys know what I'm saying? So anyway, this is kind of just giving you guys some information about it. And so it's the same for sine. We restricted the domain for sine because it's only one cycle. And you say, is that what they're talking about here? When they say, hey, this interval of one cycle, you guys remember that definition? The answer is yes, that's the interval of one cycle. So that's the restricted domain. And we'll put that there so you guys can know the details. And that's important information. We're going to revisit some of that stuff later. But we're only drawing one cycle of cosine. Cosine is defined for all real numbers, every real number. And so it's the same situation. They're going to say determine the what? Determine the amplitude, the period, and the interval of one cycle. Okay, you guys okay with that? And that's for the general version of cosine. So for example here, they'll say y is 1/2 cosine, and I'm going to say pi x. Okay, or no, let's do 4x. We'll start with that. Okay, let's close that door. Isn't that much better? It's much better. Oh, is the heater on here? I don't know. Let me get a mask on. How's that? Chills. Okay, here we go. What is this? That's not the amplitude. That's what? A. The amplitude is the absolute value of that. So I guess it is what? 1/2. Okay, you guys okay with that? Is that easy? Then I'm going to get this. Remember this K value here. We need what? The period is what? 2 pi over what? That K value. So what I'm going to say, you guys really need to know your definitions. Okay, is that right? You guys know what I'm saying? So, okay, so, I mean, we could do it a couple of ways. You can say 2 pi over 1/2. And then what else you guys need to know how to do? Right? Then we have to do some arithmetic. A whole number divided by a fraction, what's that going to be? 2 pi divided by 1/2, which is 2 pi times 2 over 1. Oh, sorry, I put 2 pi over 4. So we just have to know how to do what? Simplify a fraction. Okay? It's always good to. P equals what? How does that simplify? Do you guys know what I mean? That's pi over what? Over 2. Now, we called this the period yesterday. What color did we call it? What color was this one yesterday? Was it orange? I don't remember. Okay. Now, the interval of one cycle, right? The restricted domain that we're going to draw our cosine curve for. What's the definition? From 0 up to what? To P. Isn't that the definition? And you guys want to know something? There's a very good way to memorize these formulas. You guys know what that is? How do you memorize these formulas? Right? Every time you use it, you what? You write it down. So what I've done here is I write it down here, I write it down here, and again, if you get an iPad, you can even color coordinate it, and then I write it down over where? Down here. So notice every time I use it, I write it down. And that helps to memorize these what? Formulas. Okay? That's how I do it. So now you say, well, what do we do with this? Well, no, the whole purpose is to graph. Is that right? So they want you to graph this. Okay, now this is not going to be to scale, but what am I going to put here? You guys remember? What's the amplitude? 1/2 here, and what? -1/2 here. Okay, you guys okay with that? That's why you got that amplitude, okay? This is why you got A as 1/2. You're going to use that number here, and you're going to take the opposite down there. So this is my range for the cosine curve, okay? You guys see what I'm saying? That's going to be your range, by the way. So maybe we should even ask you guys that question here. What's the range? Set of all y such that -1/2 is less than or equal to y, which is less than or equal to positive y. We should ask you guys those things too. That's the range there. Now, what is the next thing you guys want to use here? You guys know? What's the meaning of the period, by the way? It's the length of one cycle. The period is the length of one cycle here. So we found that to be pi over what? 2. That's the length of one cycle. Okay, you okay with this here? All right, now, what do you want to do? You want to describe what's halfway. Yeah, well, what's halfway between? If this is pi over 2, remember, half of anything is to divide by 2. And then this is where the arithmetic comes in. Okay? All right, you say, what do you mean? Well, we're going to take pi over 2 divided by 2, pi over 2 times 1/2 pi over what? 4. So, ladies and gentlemen, this is the value of pi over what? 4. So we're going to get rid of this. And bring that up here. And then what else do we do? Do you guys remember? What else do we do with this? What's 1/2 of pi over 4? Okay. So you might say, do I have to do the same arithmetic? Yes. And then some people start to do it in their head. They go, okay, I know that's pi over what? Pi over 8. Okay? But you're doing what? You're multiplying fractions though. 8 pi over 8 now. So we can get rid of this. We've done the scratch work. And we're on our way. Okay, but remember, this doesn't look right. Is that right? What do you guys remember about this? You take multiples. 1 pi over 8, 2 pi over 8, and then this is 3 pi over 8. And this is going to be 4 pi over 8. And yes, that reduces to pi over 2. So, ladies and gentlemen, this is all the scratch work you guys need to do to start to find these very important points. So, like on a test, I look for those values. Okay? I look for them. All right. All right. How about this, ladies and gentlemen? What curve is this? Because now we're ready to sketch. So what do you think? What curve is this going to be? Anybody have an idea? What was this problem? What curve? Is it sine or is it cosine? So that's one thing I also look for, by the way. Do you know if it's a sine or cosine curve? Do you know the difference? What's the difference? Cosine starts where? Right here. These are the highest points. Okay? And then it goes to the x-intercept, and then it goes to the what? Lowest point. Then it goes to the what? X-intercept again. So I check, do you know which curve you're sketching? Because I'll ask, what curve is this? And there you go, ladies and gentlemen. That's all the detail that you need. And I guess I'll put that in what? Green? Because I'm saying, hey, do you know that this is a what? Cosine curve? And in fact, here's the idea too. What's special about this point and this point? These are the x-intercepts, right? What's the address of an x-intercept? It's an x value, comma 0 for y. So where are the x-intercepts at? Pi over 8, that's the location. And the other one is what? 3 pi over 8. Okay, so there's 2 x-intercepts in that interval of 1 cycle here. And how about this? I'm running out of colors. I don't know what to use. Okay, pink, I guess. Here and here. What is that? What are these locations? That's where you have a maximum value. Is that right? Maximum value. And then what's this special location? I know it's at pi over 4. That's where you have a what? Minimum value. What is the minimum value? Negative 1/2. Okay, ladies and gentlemen. So, you know, those are some 1, 2, 3, 4, 5 special points you guys want to be aware of. Where you have the maximum value, where you have the minimum value, and where you have your x-intercepts. Okay? Maybe I should even, you know, I'm just thinking of test questions. I'm like, ooh, note to self. I'm going to put that in my notes. Put that in my notes so I don't forget. I'm so forgetful. Like the next trig test. Test questions. Math 41, right? We'll say range x-intercepts max and min values. Because that's really why you're studying the graph, in all honesty. That's why we study it, so we can use it. We need that key information. Some good notes to self. Okay. All right. Now, let's give you guys another one here. Oh, we didn't do what's the interval of one cycle? We didn't answer that. We start at 0 and we go to what? Pi over 2. We're using the definition. So this is where you start, and this is where you end. This is one cycle. And so that's called the interval of one cycle, right? 0 to 2 pi over 2. That's your restricted domain as well. Because what's the deal? There's infinitely many cycles of cosine. There's only one. We're only drawing one. We're not drawing more than one. It's also what's called the restricted domain. That's how you define this. And then let's give you this example here. Because they can give it to you and they can say, how about this? 3 cosine of negative, how about this? 2 pi x. Okay, we want to do the same kind of analysis of the curve. The same analysis. All right, we ready? This value is what? A. And then, oh, what's the deal? Maybe not. Maybe not. What do we know about cosine? Is cosine even or odd? Because remember, right in here, we can't have a negative number. K. Remember this K value? K was supposed to be what? Positive. So what do we have to use, you think? Cosine is what? Is cosine even? So in other words, since cosine is even, cosine of any negative value will be what? The same as cosine of the positive value. So now we're ready. We can say, here's my A value, and here's the K value. Okay? K is the number for your period there. So our amplitude here is the absolute value of A, which is the absolute value of 3, which is what? 3. What's your period? 2 pi over what? K. Notice every time I use this, I do what? I write it down. So what's this period going to be? 1. My amplitude is 3. Your period is what? 1, ladies and gentlemen. Now, K is really known as omega in another section. It's going to be related to an angular speed situation. So anyway. What's the interval of one cycle? You start at what? 0. You end at what? 1. Interval of one cycle, ladies and gentlemen. So stop right there. Take a look at this. We're going to do some more analysis of this curve. All right, now, let's go with this now. Remember, let's look at the curve. And I think I have to. Let's do this here. Yeah. Okay. So how do I use all this information? Right? I'm going to put this line here, these important lines. You guys okay with that? So I'm saying, look at this graph here so far. That's kind of like our framework. Do you guys agree? Now I need to use this amplitude. I need that value. What's that value? 3. Then what's this other value down here? -3. So far, so good. You guys okay with that? What's your period? Isn't that the length of one cycle? And notice, aren't we starting at 0 and ending at 1 for the interval of one cycle? The answer is yes. All right. So now I guess we have to put these other important points. Halfway between 0 and 1. What's halfway between 0 and 1? Just take the number, divide by 2. That's half. Like if I said I'm going to give you half of the money I have in my pocket, half of the cash, I take how much I have, 0, and I divide by 2, and I get what? So I get to give you 0 if I'm going to give you half of my money in my pocket. What's half of 1/2? You say, Mr. Judge, I don't know. Okay, take 1/2, divide by 2. This is the S portion of the class. What's 1/2 times 1/2? Do you guys know why? Because how you multiply fractions is what? Oh, I tried to draw an arrow straight across. Okay? Is that true? You guys know what I'm talking about? So, okay, so I know this number is really what? 1/4. Okay, you guys okay with that? Now, I have to get this value over here. That looks kind of halfway, is that right? So what do? What is that number? How do I get that number? What do you guys think?
3 times 1/4.
I can do that way. How do I know it's 3 times 1/4? This distance is supposed to be what? 1/4, 2/4, 3/4. All right, you guys okay with that? Is that simple? Is that simple, you guys think? When do you want to get started on this graphing homework? ASA what? P. And I'm going to... Okay, what's left to do? What's the last thing that we have to do? Well, which curve is it? Is it sine or is it cosine? Is that important? So what do you guys know about the cosine curve? It starts where? At 3, and then it goes down over here, right? And then it goes to the lowest value here. Then it goes back to the x-intercept. Then it goes back to the largest value. So this is where you have the maximum value, min, and I always put my intercepts in what? Red, okay? Because these are called x-intercepts. So I have to sketch the cosine curve. And hard to do. There you go. Now we're going to do some Mr. Judge analysis, okay? I'm getting some ideas, ladies and gentlemen. That's not always good. Actually, it's always great. What's the analysis here? What's your restricted domain? What's the range? What are your x-intercepts? What's the max and min values? Okay, you're drawing this curve for a reason. Is that right? And I guess the author of this book doesn't ask you that, but you say, why does Mr. Judge ask you that? Because I think the author thinks that people should know this. It's obvious, right? So the author is believing. I don't believe that that's so obvious, but there's a reason why we want to sketch this curve so we can analyze it and use this information. So if I said to you guys, what do you think here? What's the restricted domain here? Right? It's the interval of one cycle. What was that? 0 to 1. Good. What's the range? Right? Set of all y such that -3 is less than y, which is less than or equal to +3. This is how we describe this range here. So we got the range. Good. Okay, where are your x-intercepts? You can say they're at 1/4, 0 as a point. And what else? 3/4, 0. Good. Now, what about the maximum and minimum values? There's 2 maximum values. How do you think we do that? Do you guys know the coordinates of the maximum value? X is 0, y is 3. X is 1, y is what? 3. Okay, so you can say 0, 3, 1, 3. So that 3 is the maximum value of the cosine curve, okay? We care about that maximum value. Outstanding. Oh, I'm filling a worksheet. Okay, now what's the minimum value? Say, Mr. Judge, the minimum value, maybe we should change the color. Where's that at? It's going to be at what? X is 1/2. And really the minimum value is what? -3. But that's the exact location on your graph. So you guys get all of this analysis here. It's not just sketching and using those definitions. This is some good stuff, ladies and gentlemen. This is really why you care about the curves here. All right? This is why you guys care about sketching the curve and using the definitions. Right in here, it's for the analysis. Because when you start working with word problems, you have to be aware of that. Okay, you guys okay with that? Oh, I'm thinking some stuff. All right. Here's the deal. Let's note, what if they give you y equals just negative cosine of, what? X over 4 now. Okay, I'm going to give you guys some time here yourself to find all those things, like determine the what? Amplitude, determine the what? Period, interval and cycle, sketch the graph. Maybe do some what? Analysis. You guys know what I'm saying? All right, give you guys some time. Let's see what you guys can do. All right, ladies and gentlemen, here we go. When you see negative anything, and notice right inside here, you don't have a negative sign. Is that true? So in other words, what does that tell you? This negative sign is short for -1. This is the A value. Oops, wrong button. Okay, you guys okay with that? So what does that mean your amplitude is? Absolute value of A, which is the absolute value of -1, which is now what? Good. Okay, you guys okay with that? That's your amplitude? Okay, what's your period going to be? It's 2 pi over k. Notice, every time I use my formula, I write it down. Now, focus right here because we got to know what k is. So if you have x over what? 4. Do you guys know what that means? Isn't that 1/4 x? Isn't that the same as 1/4 x? So what do you think the value of k will then be? What's k? K is always the number that's multiplied to what? Remember, you see kx in the general form? You guys see what I'm saying? K is 1/4 here, ladies and gentlemen. So, since k is 1/4, you say this is 2 pi divided by 1/4, which becomes 2 pi times 4/1. What's the period? Your period is 8 pi, ladies and gentlemen. Okay. And then once you know the period, your interval of one cycle from 0 to p, what does that become? 0 to 8 pi, ladies and gentlemen. All right, here's my interval of one cycle. We've been coloring that orange. It's also the restricted domain. Okay, this is why you get this. Anybody have any questions on what we just did so far on that? Right, you did some simple arithmetic. 2 pi divided by 1/4, whole number divided by a fraction. You take the whole number and you multiply it by the reciprocal. That's why it's 8 pi. Yeah. So anyway, now what are we going to do? We're going to try to sketch the graph. We're going to draw a straight line. Not to scale, but I'm going to write down here. This is my what? Range. This is my restricted domain, also known as the interval of one cycle. I'm going to have to put some values there. Is that true? Okay, I'm going to look up here. This is going to help me. What do I put? The blue numbers. What's this going to be? 1, -1. 0 to 8 pi. Easy breezy. So far, so good. Okay, now what do I do with this? Right, these are the x values. These are the y values. Okay, what do I do now? What's halfway from 0 to 8 pi? What's half of 8 pi? 4 pi. What's half of 4 pi? What's this number here? You say what? 1 times 2 pi, 2 pi times 2 pi is 4 pi, right? 2 pi, 4 pi, what's this? 3 times 2 pi, 6 pi. 4 times 2 pi is 8 pi. So ladies and gentlemen, you can really very simply deduce all those what? Important locations here. So what curve is this, sine or cosine? Cosine? It's a cosine curve? Okay, what does that mean? You start where? Max. And then you're going to go to the what? X-intercept. And then you're going to go to the what? Minimum. And then you're going to go to the what? X-intercept. And then you're going to go to the what? Maximum value. Is that true? But what about A? You go, Mr. Judge, this would be true. Halloween's coming, ladies and gentlemen. I don't even want to bring it up. What do I call this? The ghost curve. The ghost curve. I don't even want to bring it up. You guys, anybody here believe in ghosts? How about this question? It's okay. Anybody see a ghost before? Anybody seen a ghost before in their life? You got attacked by a ghost? Wow. Anybody else see a ghost? What did the ghost do? Oh, really? Lifting you up by your hair? Never went back to the house? What did your cousin say?
He was freaked out. He was paralyzed. My mom used to, we were babysitting.
Mm-hmm.
My mom just grabbed me and my brother and told them that they want to come get in the car, but we just left the house.
Mm-hmm.
I didn't go back to the house after that.
What about the people that live there? Do they have any other ghost stories?
Yeah, my cousin said that his mom, that their chairs were stacked in the morning, but nobody slept their chairs.
Where do they live? I'm just curious.
They live in East Falls, by Whittier Boulevard.
Okay.
Trust me, it's not worth it.
You know, you probably don't want to go there. Anybody else? That's a pretty good ghost story. Man, you're kind of iffy on that one? Okay. What's the difference?
I don't 100% believe in ghosts. I believe in spirits.
You believe in spirits.
But it was in a movie theater. Like no one was standing up, but there was just like a weird dark shadow that just passed down
Oh,
the staircase, even though everyone was sitting.
probably wanted to see a movie. Where was that location? Like Old Hollywood or something?
I think it was in no, I think it was in the Pumpkin Hills Mall.
Oh, in the Pudding Hills Mall area? I've been there. I've watched movies there. Oh, shoot. Yeah, yeah. Okay. Interesting. Well, I'll share with you a ghost story when we get a chance. I'm too scared. Why do I say the ghost curve? Because this starts with A being what? Negative. Is that right? What does that mean? I got to reflect this all about what? So down here, and it still goes to the same x-intercept, up here, down, and it still goes. So in other words, this is the true graph. I always put the ghost curve there, personally, only because why? Why do I put that ghost curve, ladies and gentlemen? It's used as a reference, right? But when I finish the question, I remove that kind of stuff. So, you guys might want to do the same. And I don't mean to scare you guys. Okay.
So it's just optional.
In my mind, I visualize that ghost curve. And then I reflect it all. Sometimes I put it as a dotted curve. I used to draw it this way to people. Like in past lectures, I would do it that way, and they call it the ghost curve. And then all these people would come up with their ghost stories. They say, Mr. Judge, you believe in ghosts? Yeah, I have a ghost story. I'll tell you. The Queen Mary is haunted, ladies and gentlemen. I used to think it was just a gimmick. You should draw this ghost curve. I used to thought it was a gimmick, to get tourists to come in. I admit it's cap. I went on a few ghost tours there myself, But my brother, he's another former ELAC student too. So my brother, actually, he's an engineer for the gas company. He's a big shot engineer. And he was spending the weekend with his wife there. And, you know, they're getting ready to go to dinner and everything. He's working, and his wife's getting ready in the restroom doing her hair, and something pulls her hair, maybe like pulling your hair. And then she says, Tim, stop fooling around. Stop pulling my hair. Okay, stop it. I'm getting ready. And he comes in, what are you talking about? He goes, you just pulled my hair. Stop doing that. And he goes, no, I didn't. So being a goofball the way he is, right? He goes and he gets his, because he's has like a voice recorder for, you know, the minutes for his meeting, blah, blah, blah. He recorded. He comes back and he talks into the, you know, the recorder. He says, did you pull Nicole's hair? And he records, you know. And guess what happened when he played it back? He had an answer. It's an EVP. You know what the answer was? Oh, yes. Very creepy sounding. I'll share it with you. He sent it to me. When we get a chance, I'll share it with you. Maybe when Halloween comes, I'll play it for you guys. Huh? Well, I think that it's being renovated. You can't go there anymore. It's being renovated. To get rid of the ghost curve. But that's the story. And I know it's true because every time, you know, we used to kind of get together, they would argue and fight over it because he'd always go back to the Queen Mary and take her and use her as bait. She'd get mad. Stop using me as bait. And he never was able to record anything else ever since. So all his other adventures have failed. Anyway, just true story. I'll play it for you guys if you guys don't believe me. But it has to be kind of at the end of the lecture. So those of you guys who are a bit squeamish, maybe a little scared, you should leave the room because this is only for adults. You guys know what I mean? Leave the room. Anyway, why do I tell you guys these stories? You guys know why? Because now you're going to remember when there's a negative sign, you're going to remember that ghost curve idea. There's a reason why I do this. It's not just arbitrary. Okay? It helps you remember this stuff. And whatever helps you remember is what you do. So, let's answer our analysis. You say, what's the analysis? Okay. Domain. And I'm going to actually do this a more formal way. Set notation instead of all x such that what? It's the interval of one cycle from 0 to what? 8 pi. So if you said, Mr. Judge, but they wrote it this way. This is that interval of one cycle. I know that's interval notation, then you have set notation. All right, you guys okay with that? What's your range? Notice I've been giving you set notation. What's the range? -1 to what? +1. That's all the y values, okay? Cosine doesn't go out of those values. You guys notice that? Okay. Cosine doesn't go out of those values. Range is between -1 and +1. The range is right in here, the blue. This is the orange. And then you say, can you give interval notation as well here? Yeah, but it's not called interval of one cycle. It's just the interval notation for the what? For the range. Okay, you guys remember these things? They should be talking to you guys about this in Math 260. And then I'm going to say to you guys, what are the x-intercepts? Right? Remember, the x-intercept it's when x is 2 pi, y is 0, and then when x is 6 pi, y will be 0 here. It's these values on the x-axis. It's where the curve crosses the x-axis at 2 pi and 6 pi. So this is really the locations. Pretty good? You guys okay with that? All right, now I'm going to color these two special points here purple. Here and here. What points are those? Those are the what? Minimum values. Good. Minimum values. Is that right? So if I want to summarize the minimum values, what is the location? X is 0, y is -1. X is now what over here? 8 pi. Y is -1. So This is, we don't put 0, but okay, I guess we can. These are the locations where you have minimum values. Okay, the y values are the minimum values, but the x values are the location here. Okay, so just to kind of let you guys know, the minimum values are here, -1, x is the location. And then here, let's get out the pink. What's special about that location? That's the maximum value, is that right? And we care about that. Maximum value occurs where? When x is 4 pi. What's the maximum value? +1. So to let you guys know, yes, it happens when x is 4 pi, but the maximum value is 1. So you can write that down there. Maximum value, 4 pi, 1. And that's the real reason, ladies and gentlemen. You're looking at the reason why we sketch that curve and look at these details, okay? To find the maximum values, the minimum values, the intercepts. This is the reason. Okay? You guys okay with that one? Let me look at something here. So what do you guys think? Is that pretty easy? Okay, fine. What do you guys think? Pretty good? We should have a quiz on this, though. It's a prize quiz. What do you guys think? Question. What do you mean decimal points in the period? Yeah. Well, in all honesty, like you're looking at the period here being 8 pi. Did the book give you that kind of question? You know what the approximate value of pi is? 3.14. So in all honesty, if I get out my TI, question is, what if there's decimal points in the period? I don't think they'll give you that, personally. They're giving you symbolic values. Pi is about 3.14. So 8 times that number, we're going to see what that is. Okay? So if I said 8 times 3.14, really, the reality, this is 25.12. Okay? So the reality is that this is actually 25.12 for that period. This is the decimal representation of it. We write it here. Let me go back so you guys can see. We write it as just symbolically 8 pi. So, but it is a numerical value, 25.12. So you're right about that. I don't think they usually give you decimals. You just go through the symbolic notation. There's an expectation that you do know what pi, the numerical value of pi. And, and maybe in a physics course and maybe not. You see, you get to one of the reasons why we go through these details, and you're going to see with some word problems. These details are all extremely important and vital to know the curve, the maximum, minimum values, and the intercept points, the range and domain. Because there's physical phenomena, maybe ghosts, I don't know, that are modeled by trig functions. So maybe they might ask you, give me the numerical value of it. But in a math course, we generally put it as symbolic, generally speaking. Okay? Now, I got more for you. We have something called a horizontal shift. Okay? Do you guys know what horizontal shifting actually is? Like if you take Math 260, even 125, it depends on the course. If you guys take a pre-calculus, you study curves and both vertical and horizontal shifting. What does horizontal mean when they say horizontal shift? Yes, it's actually when you move the curve. We use this phrase either left or what? Right. It's horizontal shift. Now, that's generally speaking in mathematics. In a trig course, though, They call this a phase shift. Okay, and I already used purple. I gotta probably have to use another color for phase shift. Darn it. What do we have? Maybe green. So in a trig course, trig calls this phase shift. I'll do blue, little OCD. Okay, so this is known as phase shift in a trig course. And probably in a science course too, but it can change names depending on the topic. Okay? And it's represented in trig by the letter B, by the way. Okay, and it's just really a left or right movement. We see, there's somebody trying to get in? No, maybe not. Maybe they're just standing by the door. So when you look at your book, and you might say shifted sine and cosine curves, right? You got the general versions of these. Again, y equals a sine here. K, x minus b. You have y equals a cosine k x minus b. And so you already know what A is. That's your amplitude. Well, it's not. The absolute value A is your amplitude. You guys know what K is. Well, you're going to find out what that is physically in another section. It's kind of like your angular speed. But notice what they did here. You now have what here? That B value. Okay? So you're going to see trig equations that look like this. And if you're moving left or right, you want to know what changes? The interval of one cycle changes. You start at B. This is the important point. You're going to now start at B. Your starting point is now at B. Okay? And you're shifting. You still need the period, but you're going to end at the period plus B. So the others are still the same. Your period is still going to be what? 2 pi over K, okay? And the amplitude is going to still be the absolute value of A. It's just you're going to now start where? At B. And you're going to end at the period plus B because everything is shifted. Okay? It's all going to be shifted now. So for example, just to kind of look at a first example, they say y equals 2 sine of x minus pi over 4. Okay? Notice it's going to be in this general form here. So you say, well, what do I need? Well, my amplitude is what? The absolute value of 2, which is 2. Is that right? What's the period if it's 2 pi over what? Over K. You guys notice? Look up here. You say, Mr. Judge, what number is multiplied to that x minus pi over 4? Your K here is going to be now what? 1. Okay, so the period still is going to be 2 pi over 1, which equals what? 2 pi. Okay? So here's my period. And I guess this was orange. Do you guys want to tell me what the phase shift is? This is an important detail. You got to be very careful. You see in both of the formulas, it's x minus. You want to know what b is? B is always the number that comes after where? The subtraction sign. So do you guys see minus here? That means this is your what? Phase shift. Your phase shift, ladies and gentlemen, B is pi over what? 4. It is always the number that comes after the subtraction sign. Okay, you guys see that there? X minus B. B is the phase shift. So the interval of one cycle now, by definition, is B. That's where you start. And then B plus what? P is where you end. So this is where we're going to do some more arithmetic, right? Because if B is pi over 4, this is your new starting point. You're going to start at that B value. But then you say, where do I end? Well, you're going to do some arithmetic here. This is going to be here what? Yeah. Pi over 4. What's your period? 2 pi. So this is what we're going to have to focus on, right? This is where you end. So now you say, well, I don't know what a fraction plus a whole number is. I'm going to share with you guys, it's a very easy way to do this kind of arithmetic, okay? Very simple way. Do you guys remember how to add fractions? You have to have the same denominator. Is that true? So these fractions are not like. They're different. Here's what we can do. What's the denominator over here? We need to multiply top and bottom by that number 4. Because isn't 4 over 4 1? It's 1, is that right? So in other words, this is the same question. Pi over 4 plus, how do we multiply fractions? You guys remember this? Straight across. So what's 2 pi times 4? What's 1 times 4? Don't they now have the same denominator? Aren't they now what? Like? So what do we do now? Pi plus 8 pi gives you what? It's 9 pi over what? 4. You guys have added fractions with different denominators. So the moral of the story is you're going to start at pi over 4, and you're going to end at what? 9 pi over 4. This is your new interval of one what? Cycle. Okay, you have a starting point, and you have a what? Start, and you what? End. So this is where some of your work's going to be. Okay, this is where you're going to have some work here. So you guys remember some of these kind of things, some arithmetic with fractions? Should we actually give you some homework on that? Work on some arithmetic with fractions and homework, because I give you the S portion here. You guys know what I'm saying? So this is how that works. But anyway, all right. Now, we do have a few minutes, so I'm going to say to you guys, how would you start to do this, right? Here's how this works. Notice, what is the phase shift here, that B value here? If we go back to B, what kind of movement is this? Do you guys know what this means? If you're starting at pi over 4 now, right? You're starting at pi over 4. Where are you ending? At 9 pi over 4. Is that true? So what's my point here, ladies and gentlemen? You're shifting this curve where? To the right. So the B value, just so you know, just to summarize, the phase shift of pi over 4, this is moving to the what? To the right. To right horizontal shifting. Because this is your new starting point here, pi over 4. Notice your amplitude was what? 1, right? So this is 1, and this is what? -1. So far, so good? So I want to emphasize that B value in green, you shifted the whole thing, what? A distance pi over 4. So that's why you want to find that B value. That's the starting point. Now, what kind of curve is this, by the way? Do you guys know? It's a sine curve. So, yeah. Oh, was it 2? Oh, you're right. It is 2. Good. Thank you. It was 2. Or it is 2. Does your amplitude change when you have a horizontal shifting? The answer is no. It's just where you start and where you end change. So this is a sine curve. Is that right? You guys with me on that? So where does sine curve start? Right here. And then you go up to the maximum value. You come down to the intercept. And then you go to the minimum value, right? And then you get back to the intercept. So I want to sketch this here for you guys. But as you know, we need to know what? This value, and this value as well. Because the whole idea is to do some analysis. But I want to share with you first, you have x minus a b value. That b value is where you now start. Right here. This is where you start. So you do have to add it to the period to find where you what? Where you end. 9 pi over 4. Okay, you guys okay with this? So now the question's going to be, how do we get all those important detailed points? Do you guys know? What do you think? How are we going to get those points now? Let me give you some more information. Definition, if I say to you, what number is midway between what? A and B. Do you guys know? What number is midway between A and B? Now, there's a formula you guys use. The midpoint formula is found when you add the numbers and you divide by what? 2. Okay, so you need to know the two numbers. Midway between A and B. So for example, if I say what number is midway between 1 and 3, you're going to tell me, I know it's 2. You take 1 plus 3, divide by 2. What is this going to be? Isn't that 2? So far, so good. What about midway between 1 and 4? How would you find that? 1 plus 4 divided by 2, which will give you what? 5 over 2. Numerically, that's 2.5. So dealing with the S portion of the course, finding midway here. Okay, you guys okay with that? How about what's midway between 5 and 25? How do you find that midpoint? You add the numbers, you divide by 2. What's 5 plus 25? What's 30 over 2? Is that 15? So far, so good? What's midway between 10 and 31? You take what? 10 plus 31 and you divide by 2. What do you guys get there? 41 over 2. What's that going to be? You go, I don't know. 41 divided by 2 gives you, this is the S portion of the class, right? 21 point what? 20.5. You guys okay with that? 20.5? Of course. You go, what do you mean, S portion? Yeah. I'm going to give you guys some review. In the S portion, we don't have to have the S portion at the end. We can have it in the beginning. We can have it in the middle. So anyway, I'm going to give you guys some time this morning to warm up. And you say, why am I warming up with this arithmetic? Because I think we may have to review some of this what? Arithmetic. Is that right? So some of this arithmetic may come up with us. And so because of that, I'm going to ask you guys to try to warm up this morning with some arithmetic. It's designed to help us. Okay. Here we go, ladies and gentlemen. Here we go. Okay. So remember, we're doing the S portion of the course, which is review of adding what? Whole numbers with fractions. Okay, so for number 1, anybody remember, how do you do these kind of things? You got a whole number with a fraction. The fraction is 2/3, where the denominator is 3. Why did I highlight that 3? Do you guys remember? In order to add fractions, they have to have the same what? Denominator. Is that right? So here's a little trick. I'm going to put 3 over 3 times that 1. Why did I use 3 over 3? Well, the 3 over 3 is the number 1, and then 1 times anything is itself. So in other words, I didn't change this equation at all, right? So what I'm saying is really this. If I do 3 over 3 times that 1 plus 2/3, I'm not changing my equality. Okay? You guys okay with that? So in other words, this is kind of a very nice way to add a whole number with a fraction. So you got 3 times 1, that'll be 3 over 3 plus what? 2/3. Now you're happy. Why are you happy? Same denominator. Okay, what do you guys do? You guys remember? You got this algorithm, a plus b over c plus b, the same denominator. What does that do? You get to add the numerators and keep the denominator. So what is this going to give you? You can say, is that 3 plus 2 over 3? The answer is yes. And what does that equal? Do you guys know? This equals what? 5/3. So, ladies and gentlemen, you do have what? A way to add fractions. Right? You guys okay with that? Is that clearing out the cobwebs? Do you guys remember? Hopefully. Okay, so there you guys go. Pretty good. Number 2. 3 plus 1/5. All right, so what is this process gonna be again? Remember, this is equal to what? You got a 3 plus 1/5. What do you look at again? The 5, right? So what do I do? Right? That's really the number 1. Okay, and then now, ladies and gentlemen, that gives you 15 over 5 plus 1/5, right? I'll lower the applause. Anyway, what's 15 plus 1 now? 16 over 5. And you are what? Done. Clearing out the cobwebs. Okay. 2 plus 1/2. What does that give you? Right? You get what? 2 plus 1/2. So what do you guys know about this 2? 2 over 2, 2 over 2. 4 halves plus 1/2. What does that give you? Isn't that 5 halves? So, ladies and gentlemen, there you go. Okay, number 4 now. 2/3 plus 1/2. Let's see if you guys remember here. What do you guys know about this situation? Do you guys know? Well, first, before you do that, what do you guys want to notice here? Well, you got 3 and you got what? 2. Is that right? All right. Those are different. Could you use this algebraic fact of adding fractions if they have different denominators? Say no, because why? Denominators are what? The same here, right? So here your denominators are the same. Now you have denominators that are what? Different. So generally speaking, A over B plus C over D, different denominators, okay? I'm going to have you guys remember, you're going to have to cross what? Multiply, right? And you say cross multiply, what in the world does that even mean, cross multiply? Here's what I mean by that. You're going to what? See this? This is cross, and this is cross. And you go, well, what are you talking about? I'm going to show you guys another algorithm. The denominator is this BD stuff. Multiply that straight across. The numerator now is what? AD plus what? BC in gray. So you're going to multiply diagonal across for the numerator, and you're going to keep this sign. Even if it was addition or subtraction, you keep this sign. If it was subtraction, you know, same thing. So I can put addition or really what? Subtraction, so you guys know. And then multiply the denominators together. And this is kind of a formulaic approach based on this idea called cross multiplication. So I don't know if you guys knew about this. Anybody here know about that? Right? You get to use this really when you have different what? Denominators like you see here. Okay? So you say, what does that mean then? Well, this is what that means. You take 2 times 2 plus 3 times 1 in the what? Numerator. Is that right? What do you take in the denominator? 3 times 2. So, what does that give you? Isn't that 4 plus 3 divided by what? 6. Right? You guys agree with that? Now, what's 4 plus 3? The answer is 7, 6. Okay? Number 4. Number 5, we get to do the same exact way, right? We get to do that the same way. So we're going to copy. And paste. So notice again, different what? Different denominators. So what are you free to do when they're different denominators? Right? You get to do your what? Cross multiplication. So you say, is this 1 times 5 plus 4 times 2, everything over 4 times 5? Notice what I did. Numerator, what? Denominator. So you get 5 plus 8 over 20. What's 5 plus 8? 13 over 20. Can you simplify that fraction? No. And then you're done, ladies and gentlemen. There you guys go. Easy what? Peasy. Fresh and squeezy, I guess. Okay, you guys remember these things? These are all arithmetic. So what about number 6 here? So you notice for number 6 as well, you go, wait a minute. I have different what? Denominators. These are known, by the way. What is this? Do you guys know what this is known as? We call that something. What do we call it? These fractions are what? Unlike. What's an unlike fraction? A fraction with a different denominator. That's all. What are like fractions? Fraction with the same denominator. Okay, so you're going to cross multiply. You're going to use your algorithm. And you guys are free to use this algorithm in any math class or any other class that you guys take here. 4 times 2, right? So let's take a look at this. Six plus 4 over what? 8. Which gives you 10 over 8. Now, what do you guys know about this situation? Yes, you can reduce your fractions to lowest terms. Do you guys know how to do that? You guys know how to do those kind of things? Reduce to lowest terms? You guys want to know what I use? Factor trees. What are factor trees? You guys know what a factor tree is? Two numbers multiplied together, that equals 10. In fact, not just two numbers, two prime numbers. What are two prime numbers multiplied together that give you 10? Right? 5 and 2 or 10 and 5? Okay. Now, what about 8? Give me two numbers multiplied together, hopefully prime. If not, 4 and 2, right? Notice this. 5 and 2 are prime, but 4 is not. So then I have to repeat the process for the 4. Give me two numbers multiplied together that give you what? 4. This is going to be what? 2 and 2. So in other words, ladies and gentlemen, this is how I reduce my fractions. This is going to be replace the 10 with 5 times 2, replace the 8 with 2 times 2 times 2. Right? And then what do you guys do with this? Do you guys know? You have the cancellation property. What's the cancellation property? If I have one number times another number, same number down there times another number, I'm going to put a heart down here. What's the cancellation property? I'm free to what? Cancel. You must have multiplication and multiplication. So here you say, can I get rid of the 2 and the 2? The answer is yes. You can only get rid of one of the 2's. This is using what we call the cancellation property. Okay, so what's your final answer here? That's 5 over what? 2. Is that true? Okay, you guys okay with that? What does that mean? It means you're done. Okay, you guys okay with that? It means you're done. You simplified this fraction. This fraction is really what? I think it's 5/4. Sorry. I have to multiply. It's 5/4. So you said, hey, Mr. Judge, I reduced that earlier and I got 5/4. Well, you're right. Okay, is that clearing out the cobwebs? Hopefully. Hopefully. Now, number what? 7? Oh, combine like terms. Do you guys remember what that is? What's combining like terms? What do I mean by combine like terms, right? Let's go down here. This is review. It's important review. Remember, if you had 2x plus x, do you guys know what that means? If you had 2 apples plus an apple, what does that mean? You got 3 what? Apples? Does that make some sense? What's 2x plus x? 3x. So what would 2 pi plus pi actually be? 3 pi. Is that true? You guys know what I'm saying? Now, when you just see a pi there, what does that mean? How many pies do you see? That's 1 pi. You guys okay with that? They don't put the number 1 there, do they? Okay, now here's what I mean by this. You can also use this idea here, because this is what people do. So if you had 2 pi plus 1 pi, you know, make sure you put that 1 there. You're using really the distributive property. You guys remember? Right? You go, what's the distributive property? Well, if you got A, B plus C, that's AB plus AC, because we get to distribute. There's your algebra distributive property. But you're doing it kind of backwards, so you guys know. So that means here we are free to do what? Take the 2 plus 1, and that gives you what? 3 pi. So that's the same exact what? Answer here. Okay? But it's an important idea to know that that's really what your brain's doing when you say you got 2 apples plus 1 apple and you go, I counted, or your brain really did the distributive property. You take the 2 and the 1 and you add that, but you kept the label of an apple. Well, you're going to keep the label of a pie here. So this is where some people may go, oh, what about this S portion? You know, I guess you have to show people review this kind of information, right? And we go down to 8. And the reason I brought up that property here is because why? Pi over 2 plus what? 3 pi, right? Sometimes people are going to look at this and they're going to say, I don't even know how to do that. Okay, you guys know what I'm saying? So what I'm going to say is, think of it this way. Pi over 2 is really what? 1/2 pi. You guys okay with that? Then I'm going to add a what? 3 pi. So far, so good? Pi over 2 is really 1/2 pi. Now what am I going to use, ladies and gentlemen? You know what I'm going to use now? I'm going to use that distributive property what? Backwards. Do you see what I'm talking about here? I'm going to put this what? 1/2 plus 3. And I keep the what? The pi. I keep that common term. I don't know what color to use. I keep the pi here. Guys see the pi? And what do I do with the numbers here? 1/2 plus 3. What do you guys think? And then you say, Mr. Judge, how do I add a 1/2 with a 3? Well, you guys tell me. How do you add 1/2 with 3? See that 2? What do we do there? Multiply top by 2, bottom by 2. Is that right? So you get 1/2 plus what? 6/2, and you keep the pi. And this will give you what? 7/2 what? Pi. There you go. So here's some arithmetic that's going to really be of some importance for us. You guys think? Okay, you guys okay with that? Anybody have any questions on these that we've done? Okay, this is stuff that's done in beginning algebra, pre-algebra. Number 9. Not even intermediate algebra, right? But it comes into play. That's what I'm saying. It's arithmetic is a big part of math, ladies and gentlemen. And the higher you go, the more math you're going to do, the more arithmetic you do. And that's actually a good thing. Don't look at it as a bad thing. Don't look at it like you go, oh my God, I got to do arithmetic. Well, yeah, you got to do arithmetic over and over. Well, yeah. So you take other classes, you'll do more arithmetic. So a lot of people's success comes down to really what? Arithmetic skills in some ways. I've been saying this my whole life. Pi over 3. How can we write pi over 3? Do you guys know? 1/3 times pi, right? And then how do we write pi over 4? That's a 1/4 times pi. All right, you guys see where I'm going with this? Where am I going with this question number 9? Where do you think I'm going with this? Well, that was the distributive property. Is that true? Do you guys see this here? This is important. The pi is still here. And here, this is the distributive property. Backwards again. But what's my point? What arithmetic do I need to do? This is arithmetic with fractions. I need to do what? I need to take this number and I need to add it with what? This number, ladies and gentlemen. There's addition between them. And this is still going to be my what? Pi. So ladies and gentlemen, you have all that nice color coordinated logic there in front of you. So how do you add a third with 1/4? Do you guys know? 1 times 4, 1 times 3 over what? 3 times 4, now you have your pi. So if you guys remember earlier, yes, you cross multiplied. And this has the same color, so I kind of feel bad about that. But anyway, let's do some arithmetic. This will be 4 plus 3 over what? 12 with your pi. What's 4 plus 3? So this is 7/12 with what? Pi, ladies and gentlemen. Okay? What do you guys think about that? Is that pretty good? You guys know what I'm talking about? So this is number 9. Clearing out all that arithmetic cobwebs. And then that leaves us with, what, did I skip what? Oh, is that number 9? I think I skipped 8. Did I do 8? I did 8, right? We have to do now what, 10? I did 8, yeah. Are you guys nice and warm yet with this stuff? Woo. Nice and warm now. Alrighty, here we go. You guys ready for this? You guys tell me, what do I do? Now that you've seen a few of these things here, what do I do? What's my first step, really? One half pi plus what? 1/3 pi. Is that right? So far, so good? You guys see the pi here? Alrighty. Now, what about this? I have 1/2. I have what? 1/3. You take 1/2 plus 1/3, and then you have pi. 1/2 plus 1/3. So, what's going to happen? What do I write down next? Are they like fractions? They're not, right? So what do I do? 3 times 1, 2 times 1, 2 times 3. Is that true? So you get 3 plus 5 over 6. Pi, what's this? 5/6 pi. And there you go. All right, ladies and gentlemen. What do you guys think? Is that pretty good? Now you say, Mr. Judge, why are you having us do this arithmetic? Well, where do we leave off? Do you guys remember where we left off? We were sketching these curves. Is that right? Remember we left off in our notes? And by the way, if you wanted to double check your notes, what could you guys do? Right? Can't you go back, like I mentioned earlier? You got these videos that you guys can go back and look at. And maybe you say, oh, there's some notes I got to take on this, right? So remember yesterday I said we're going to have to get all these points, right? Remember this one? You guys with me on this? Okay. I'm going to give you guys some advice. You got the interval of one cycle. Remember that interval of one cycle was what? Where you start is pi over 4, and where you end is what? 9 pi over 4. And you guys remember the midpoint formula I gave you guys? What's the midpoint formula? So, yeah, you guys remember that midpoint? Let me do it this way here. So we know we start where? We start at pi over 4. We end where? 9 pi over 4. Okay? You guys ready for this? Here's where you guys start. This is what you're going to do first. You're going to find the what? The midpoint. So what I'm trying to find is that midway between what? The pi over 4 and the 9 pi over 4. So far, so good? That's your first thing. So I'll call this m if you like. And what's the midpoint formula? Pi over 4 plus what? 9 pi over 4 divided by what? 2. So far, so good? I'm using that midpoint formula I gave you guys yesterday. You go, what? You did? You gave us a midpoint? Yeah, let's find it. There we go. That's not it. There we go. The midpoint between any two numbers. This is what you do. You add them, you divide by 2. This is also called the average of two numbers, by the way. Okay, in case you guys didn't know, you're getting the average of two numbers, midpoint between 2. So, ladies and gentlemen, this is good stuff here. So then you say, but how am I supposed to add these? Did we just go through some of the S portion of the course? You guys know what I'm saying? So what is this answer? Do you guys know what this answer is? Right? Do you guys know you have to do what first here? Don't you have to add these first? So what are you guys going to get? Remember, what number is in front of this pi? So it's 1/4 plus 9/4. What's 1/4 plus 9/4? 10 over 4, and that's going to be a pi. Is that right? Okay, so what we did, ladies and gentlemen, is we added that numerator. It has the same denominator. Where's my sound? You guys okay with this? Now, what did I say yesterday this meant? You're dividing by 2. Isn't this 10 fourths pi divided by 2? Notice what I'm giving you every detail. People like the details, is that right? What does it mean to divide by a whole number? To multiply by what? The reciprocal of 2. Flip 2 over. And then now, what does this mean? You guys know? I get 10 pi over, what's 4 times 2? Well, it is 8, but you might say, hey, Mr. Judge, should I write it as 8? And I'll say, that's up to you. But what do you always have to do with every fraction? Do we see 10 over 8 already? I think I've seen that one already. I know what this is. What's this? This is 5 pi over what? 4. So, ladies and gentlemen, this arithmetic is there, 5 pi over 4. What you guys found is really what? That midpoint. You got to do that again. 5 pi over what? 4, ladies and gentlemen. Okay, did you guys know that, by the way? Anybody here know that you had to find that midpoint that way? Add the two values, divide by 2. Maybe you did, maybe you didn't. But you're now on a spot where people have to do some arithmetic. So that's 5 pi over 4. Okay, you guys okay with that? Now that you did that first, what do you think you have to do now? Yeah, you're going to have to find this what? The midpoint between these two numbers now. And with practice, you get pretty what? Good at it. But if you never practice, are you going to get good at it? What do you guys think? Not, I'll tell you, yeah, unless you're a genius, I'll tell you something, a little secret. At one point, I had the youngest kid in college in my math classes. His name is Moshe Tavelin. Maybe about 10 years ago. So he was like 10 years old, and he was in like statistics. Then I had him for the calculus sequence. I think he graduated from college here, an AA degree, at the age of 12. Isn't that amazing? Imagine he finished the calculus sequence at the age of 12. Is that kid a genius? Let's see if I can find it even. You guys aren't going to believe me. There he is. There's my class, ladies and gentlemen. They came and took a picture of him in my class. He's started at 10. That was a statistics class. Yeah, I'm here actually. There you go, Mr. Judge. There you are. Yeah. Look at that guy. Yes, thank you. Not bad, right? Not bad. Not bad. So there he is. You want to know something about him at 12? Would you say he's a genius? He's the hardest working student I ever had. Hardest working? I thought when you're a genius, you know how to do everything without knowing how to do everything. The answer is no, that's not the case. Even geniuses have to what? Work, do homework, have to study. And he had to do the same thing. He had to go through the arithmetic. He had to do the work. He had to study. So I'm here to say to you something very simply, that just because you're a genius does not mean you don't have to do this work. They just do it. And I think the best thing I can say about Moshe is simply this. He's a hardworking student. He wasn't the best student I ever had, one of the hardest working I ever had, and still had to do the work. So that should say something to you, I hope. Here's what this means. Here's what I learned as a student learning mathematics who didn't get out of algebra in high school. Well, I did. I got out of beginning algebra. I did. Started in geometry at ELAC and took Math 125, blah, 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 all that stuff. You know what I learned how to do? You know the difference between the Daniel Judge in high school and the Daniel Judge in college was? I did my homework every day. That was the difference. It changed my life. Now, I've been teaching for a while, and I'm smart enough to know not everybody does their homework every day for whatever reason. It could be a lot of reasons. Maybe you're depressed. And you say, homework just depresses me more. You're going to have to break out of that because you got to break out of that because not doing your homework will even make you more depressed. You guys see what I'm saying? Maybe you have too much commotion going on at home. Well, then don't go home. Go to the library. Study there. Keep you warm. Keep you cool. Get to enjoy the AC. You guys know what I'm saying? That's what I would do. Spend my life in the library. But sooner or later, you're going to have to make a decision. Sooner or later, you're going to have to decide, what are you going to do? And that's what I had to decide. What am I going to do? Am I going to be still making those excuses I did in high school and not doing my homework? Or am I going to change and say, okay, I'm going to start doing this homework and get it done? I made the decision to change. I didn't make the decision to stay the same. So some of you guys are at that point, really. You're kind of on the fence. And some of you guys are really testing Mr. Judge out. I already know. Is he really going to allow me to, or is he really not going to accept any late homework? What about making up tests? I want Mr. Judge to go back to the high school mode where I dictated terms of my grade, not him. And you're going to learn it ain't going to be that way. Trust me on that. You are now stepped into a different world. So I already know all those things ahead of time. I already know people are going to have to learn. And you're no different than the calculus students or even the statistics students. Students there do the same things. So I just want to let you guys know that this is an effort that's made to help yourself. And even geniuses, what? Need to do the work. It's just that simple. The difference between someone who is successful and someone who isn't that they're smarter. It's not an issue of intelligence. It's an issue of what? Work ethic. Nothing more. They're going to put the work in. That's it. So even if you get frustrated at times and you say, oh, how are you going to get this one? Well, I'm going to take pi over what? 4 plus 5 pi over 4. I'm going to divide by 2. And I know my numerator is simply 6 pi over 4, right? And I divide by what? 2. And I say, oh, this is 6 pi over 4 times what? 1/2. Some of you guys are going to tell me, hey, can I take the 2 and go into 6? Do I have to do factor trees? And I'll say, no. What will you end up with? That's 3 pi over 4. So did I have to learn these things myself too? Yeah. Not a big deal. In fact, once you start getting successful with this, right, and start getting the right answers, you know what you start to learn? You start to say, you know what? I think I like math more than I did yesterday. You know, every day you like it more and more because you're successful at it. But you're not going to be successful unless you put that energy. It just doesn't work that way. Good luck to you. You notice most of the world thinks that way? They think being successful is out of your hands. It's a matter of, I wasn't born smart. Or, you know what? I wasn't born in the right family. Well, you guess what, ladies and gentlemen? You don't want to hear my family drama. You guys don't want to hear my stories. I could tell you stories. In fact, if I told you my personal stories, you'd probably be in tears. You guys see what I'm saying? We all have a story. The difference is maybe I just decided at one point, I'm going to change this story. I'm going to change it. It's not going to be, it's not going to define me. The horrible situation I was born into, the nightmare I was born into, is not going to define me. I'm going to move forward. That's the decision I made. So adding fractions may seem like a chore. It may seem like, boy, why do I have to do this anyway? Well, because it's going to help you more than you realize. 5/4 plus 9/4 divided by 2. What is this? Isn't that 14 pi over 4 divided by 2? Notice the work I do. Is that right? Isn't that the same exact algorithm? So then 2 goes into 14 how many times? So the answer is 7 pi over what? 4. And ladies and gentlemen, I have completed the task. 7 pi over 4. And that's going to be what you need to do just to graph this function. I even forgot what function that was from yesterday. Jesus. Where are you? Oh, you're right here. You guys remember this? This is when we introduced what? Phase shift. This is introducing phase shift, ladies and gentlemen. So anyway, that's this function. Hey, I wanted to put it up here. Darn it. Okay, I'll put it here. So let's kind of go back and think a little, okay? Let's go back and think. I'm going to erase all this arithmetic. It's all my scratch work for doing one question. What kind of things did we talk about yesterday, thinking about and doing? What was kind of important here? Remember the interval of one cycle? What about the analysis? Your interval of one cycle was from what? Pi over 4 to what? Yeah. And you said, well, is that related to that restricted domain? Yeah. So the restricted domain, we use D. So develop x from pi over 4 less than or equal to x less than or equal to 9 pi over 4. We're writing this in set notation. But the interval notation is there. We want to know that that's our restricted domain, right? And what's your range? Can't remember the colors we used yesterday. Your range is between what? -2 and +2. So, again, those of you guys that are in that, well, this is actually part of the course, domain and range. And then what's so special about these points? Remember the analysis? Here, here, here. What's special about those? X-intercepts. So they have points, they have locations. We can say the x-intercepts happen when x is what? Pi/4. X is what? 5 pi/4. And x is what? 9 pi/4. So we'll take a look at that. But I want you guys to see that here. Aren't those very special points? Okay, remember the whole purpose is to do the analysis. This is actually why you had to find those locations. And then if I said to you, this value and this value, and I know they're both purple, but maybe I should change the color. Purple and what? Pink? I mean, on my end, we can tell the difference. What's special about the purple point? That's the maximum value. The maximum value, ladies and gentlemen, of the function is 2. But what's the coordinates? X is 3 pi/4, y is 2. See, there's a reason why they want you to find that numerical value. That's why you don't want to make it blank, because you want to know at what value of x you get that maximum. That's at 3 pi/4. And then the other value is what? The minimum. What's the minimum value? -2. Is that right? What's the location there? Oh, it happens at 7 pi/4, you'll get a -2. That's just the address of the point in terms of our xy coordinates. So, ladies and gentlemen, all of this detail is important just to look at a curve and understand it. And you got to do that before you even use an application of it. Because all these important values I looked at here for you all have great meaning for us. And, this is what I say, the analysis of this all. So it's important details. Man, it's so important. You want to know what I was busy doing? I don't know if I can send this to you guys yet. But you know what I spent my time? I spent some time doing this. I'm gonna open it up. Let me open this up. Microsoft Office. This is what Mr. Judge does for fun. Well, between meetings and blah, 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 blah. All this ridiculous stuff I got to do. Come on, document. Please open Word. Okay, maybe you can't see that, but I'm going to do something here. Let's see. Let's see if I can drag it in. No, it doesn't like me dragging in this document here. Okay, here's what it may like me doing. I'm going to print this document up so I can put it in our screen here. Okay. Although I'm not done with it. Oh, geez. There it is. There it is. Come on, document. Oh, there you guys can see it now. What do you guys see there? I'm asking in this, determine the amplitude, period, interval of one cycle, restricted domain, range, x-intercepts, minimum value, maximum values. Okay? I don't know yet. And then look at the next page. I got more to do. And then look at the next page. I did somewhat kind of shifting. I added the phase shift we started talking about yesterday. And then I added here a vertical shift. You go, vertical shift? Yeah. Some of your homework questions, that author gave you vertical shifting too, moving up and down. We've yet to talk about that. Because we have to talk about one of the most important things here, which is really what? Let's get rid of that. Finding these what? Locations. Because they're all vital to the analysis of what we're doing. So we have to learn how to do some of that arithmetic. Now, some people don't remember how to do that arithmetic. You know? So if you don't remember, I would say today's a pretty good day because now you get to what? Do some arithmetic. You guys see what I'm saying? So if they gave you now, I'm going to look at this sheet. I'm looking at phase shift, personally. This is the one I did. This might be for future students. What was this one here? Sine. I'm going to do a cosine. Y equals, yeah, I know they can't see it. I'm going to say cosine. I'm going to do this. X plus O. I'm going to really give you guys a good one here. Okay? They can't see it. But I just took one out of my personal worksheet. That might go on my website in the future, blah, 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 blah. I don't know. That might be for future trig students because you already have your homework on this. Is that right? You already have it. So to give you extra is kind of cruel. Is that right? Do another 40. Here's what I want to remind you guys. Looking at our time. We did a little bit of S today. What does the S stand for again? Supplement. Here's an important detail. What do you guys see that's different about this example than what you're seeing here? You see this sign here? I don't even know what color to use. I don't know. Okay, gold, I guess. You see a plus. What should you see there? A minus. Is that true? You go, darn it, they gave me a plus. Okay. Well, change it. You say, what do you mean change it? Change it to a what? A minus sign. You say, I can change it to a minus sign? I'll say, well, not really. But what's the opposite of a negative, ladies and gentlemen? You guys see that here? You guys see what I'm saying? You now have a what? Negative sign. What's a minus or opposite of a negative? Isn't that a plus? So what I'm saying to you guys is this. And maybe I should find some other color. I don't know what color to use. This portion is really plus, isn't it? Because it's minus the what? Minus. So you're going to have to change a plus to minus the minus because what color do we use for this? For phase shift, what color do we use? You guys remember? I think we use gold. You see what that means now? I thought we used gold. That means my phase shift is what? Negative pi over 4. Not positive pi, but what? Negative pi. And then there's a 1 there. So what does that mean about my amplitude? Absolute value 1, which is what? 1. So we have important information here. And how do we define period? Do you guys remember? That's 2 pi over k. What do you guys notice about k for cosine? K is also 1. 2 pi over 1. Why is k 1? Because there's no number here. Is that right? This is the k value, by the way. There's no number. So a is 1. We put 1. K is 1. What's 2 pi over 1 going to be what? 2 pi. So, ladies and gentlemen, we have our period, okay? We have our what? Phase shift. And we have our amplitude, okay? We have our information. Using this information, what was the definition of the interval of one cycle? Do you guys remember? It was that phase shift, phase shift plus the period now. So to get the interval of one cycle, which is what we need, we start at negative pi over 4, and then we actually add to negative pi over 4 2 pi. And you go, oh my God, is that why you did some of this arithmetic too? And I said, yes, look at that. We have arithmetic to do here. But this time, we got to see what this means here. You guys see what I'm saying? What's the work there? You already know that's negative 1/4 pi. Is that true? And you say, okay, that's plus 2 pi. So there's a couple of things happening here. What do you guys know about that 4? What do? We take 4 times over 4. Is that right? You guys see what I'm saying? So we got negative 1/4 pi plus what now? That's 8 pi over 4. So far, so good? What do we do with these numbers here? Remember? We take negative 1/4 plus what? 8/4 pi. Now, what do we remember about numbers that are negative? Negative 1/4 plus 8/4. What does that give you? Positive 7/4 pi. So the interval of one cycle, ladies and gentlemen, where we start is negative pi over 4, and where we end is what? 7/4 pi there. Okay, so this is how the S version of this works with what we're doing. Yes. What did they say? What was positive? Oh, right here. This right here. This is negative 1/4 plus 8/4. Okay, so if you said, what really happened here? This is negative 1 plus 8 over 4 times pi. So what's negative 1 plus 8? 7/4 pi. This is your interval of one cycle. So this is where you're going to start the process of graphing, right? So you go, okay. Again, this is not to scale. What was our amplitude? Okay, so this will be positive 1 and what? Negative 1, okay? And then I'm going to do something like this here for you guys. We got a real issue about this one here. Where do we start here? We start to the left. This is negative what? Negative pi over 4. And then we end where? 7 pi over 4. So in other words, we have this information here. And this is be our green. Okay. We're going to have to find again what? What's halfway? What's halfway? Do the midpoint function. And then again, over here, what's what? What's halfway? And then again, what? What's halfway? So if you said, do I take first 7 pi over 4 minus pi over 4? Isn't that 6 pi over 4 divided by 2? 6 pi over 8? And I think that's 3 pi over what? 4. So sometimes you could start to do this arithmetic in your what? In your head, if you have practice. You only get there. It's not that you're a genius. Tell your family you're a genius because you could do it, but you had to practice, right? So what about this next point? 3 pi over 4 minus 1 pi over 4, isn't that what? 2 pi over 4 divided by 2, which is 2 pi over 4 times 1/2. We cancel. This will be pi over what? 4. And then the last one, 3 pi over 4 plus 7 pi over 4, I can start to do that in my head. You know what? That's 10 pi over 4 divided by 2. Here's my scratch. 10 pi over 4 times 1/2. 2 goes into 10, 5. Oh, 5 pi over what? 4. So this will be 5 pi over what? 4. What kind of curve is this? What happens with cosine? You start where? You start up here. And then you end over here too, right? And then over here, you go through the what? Intercept. Then you have the lowest value. And you go to the intercept. And ladies and gentlemen, sorry for my ugly curve, but we are running out of time. Okay, you guys see what I'm saying? These are the fundamental things you guys want to get started on this weekend. I'm thinking of, well, I have to delete that last page. So I do have some algebra. I call it arithmetic for trig students. You guys remember? Created a nice video for that. And I'm not sure if I should even assign it. I might. Maybe Wednesday I might get a chance, maybe Wednesday I might get a chance to do some solutions for it. We'll see. So if I do get a chance to do some solutions for it, I might assign it. But it's essentially doing arithmetic. It's like the S portion, when I say the S portion of the class, adding fractions and whole numbers, stuff that you might have said, boy, I guess I really need that for the graphing questions, right? You guys know what I'm saying? Because you do. Finding midpoints and stuff like that. So I did spend some time. That has an extra page, so I'm going to have to delete that. But I might do that. And then, just to kind of let you guys know in the future, where is it? Graphing trigonometric functions. I did write something there too that I might have to in the future. Notice the things I like asking: x-intercepts, maximum, minimum values, those kind of things. And I did take it through, regular curves, and then what? Some of these others. So I might add to it. It's certainly going to be, now you have the vertical shift and blah, blah, blah. So anyway, I don't think I'm going to assign this to you guys since we already have enough graphing questions in the book there. But in case you guys cared about that, it's also here. So I might, just do that for future trig classes, But I'm certainly going to ask you those kind of questions on a test, right? And I'll give you a study guide because that's the whole point of graphing is locating the intercepts, maximum, minimum values, and seeing the curve. It's the whole real point, So anyway, that's kind of where we're at, ladies and gentlemen. So remember, we were working with left and right shift. Is that right? Horizontal shift. So what I'm going to give you guys this morning here is, I guess if I look at that, you're going to, again, remember, what are the things we care about finding, right? You want to determine again, amplitude, period, phase, shift, okay, interval of one cycle, I'll say the range, max, min, values. Okay, so you're going to determine those kind of things. And I'm going to give you guys, because we did talk about some, I'm going to look at my sheet since I have it up. Y equals maybe 2 sine of negative x minus, we'll say pi over 3. Okay, number 2, what? You can't see. Yeah, we'll get it so you guys can see. I'm just looking at a few things here. So I'll say negative 3 cosine 4 x minus pi over 2. Okay, and now let's make it so you guys can see. So I'm going to give you guys a warm up here using all the things that we were talking about. Okay, give you guys a nice warm up here. So let's get out our clock. You say, well, where is this stuff at? Here we go. Let's get out the clock. And let's see what you guys can get here with these. All right, ladies and gentlemen. Should we try these out? All right, you guys know what I'm talking about? So remember, here's some key things I'm going to highlight, right? 2. Oh. Maybe we shouldn't highlight that yet. Let's consider this. This is supposed to be the what? K, but what does K have to be? Positive. So if you said to me for question 1, you might say, Mr. Judge, K is not positive. Okay, what do they intend for you guys to use here? Right? Is sine, look at the sine curve, right? This is the sine curve here. Is sine even or odd? Sine was odd, is that right? That's an important detail. So remember on our test, we had to go through those kind of questions. Why do you think that was, right? So that we can know that I can take the negative sign, it belongs to the 2 now. Now I just have sine of x minus what? Pi over 3. And so I'm going to look at this number here, okay, because sine is odd. And then I'm going to say, well, what does that mean about my K value? Well, if it's not there, what is K equal to? Do you guys know? What is it? 1, is that right? So it's kind of like if you said, hey, is there a 1 multiplied to this? And that's what K is? And I'll say, yes, that's what it is, okay? Now, all of that's important because when you try to find the amplitude, it's the absolute value of -2, which is positive 2. Period, again, is 2 pi over that what? K, which is 1, so your period now is 2 pi. Okay? Now, what's the phase shift here, right? Remember this. This is an extremely important detail. And I don't remember what color we were using, but okay. You see that minus sign? The phase shift is always after that x minus. In other words, your B value, ladies and gentlemen, is right here. Okay, let's use green or something. Okay, it's always after that minus sign. So B is going to be pi over what? 3. All right, you guys okay with that? So, you know, you got the amplitude here, which is an absolute value of A. This is the A value. You got the period, which is 2 pi over K, right in here. So that your interval of 1 cycle, the definition, if there's a phase shift, you start at B, you end at B plus P. So here you have arithmetic. You start at pi over 3, you end at pi over 3 plus what? Plus that 2 pi. Okay, you guys okay with that? Now, you might say, well, what do I do right in here? Here's where you have to do that work I gave you guys, right? Remember that sheet I was talking about? You know, arithmetic, every trig student should know. Okay, this is some arithmetic. You guys want to know how to do some arithmetic. It's not in that worksheet. And as you guys are working that, I have some ideas, but whatever. Oh, this worksheet? Yes, the arithmetic, right? It's probably, you know, these are some good questions, ladies and gentlemen. So anyway, let's go back. So if you guys recall, what kind of arithmetic did I do last time? Do you guys remember? What am I talking about? Pi over 3 is a fraction, right? 2 pi is a whole number. What do you guys need in order to add these numbers here? I highlighted red. What does that mean? Multiply the top by 3 and the bottom by 3. Okay, that's how you do this here. So you end up with, let's see what we end up with, right? Pi over 3 plus what? 6 pi over 3. Now you have the same denominator. You can add these. What's pi plus 6 pi? It's 7 pi. So ladies and gentlemen, this number here is 7 pi over 3. So your interval of 1 cycle, which they want you to probably sketch, starts at pi over 3 and ends at what? I don't know what color. 7 pi over 3. Pink, maybe. My favorite conic section is an ellipse. Here's your interval of 1 cycle. This is also, what did we call this last week? The restricted what? Domain. So you guys want to know that as well. It's your interval of 1 cycle and restricted domain. Because when you sketch sine, sine is a function that is periodic. It goes on forever. To the left and right. We're only going to look at 1 cycle of it. Okay? So this is the main idea behind what you're supposed to do. And then now what I say to you guys is we're going to use this information. Okay, so now we use it. You say, well, how do we use it? Well, it's not to scale. What was the amplitude again? So I have to put positive 2, negative 2 on the y-axis and the x-axis. Notice what this means since you're on the topic. What's your range? Set of all y such that what? Negative 2 is less than or equal to y, which is less than or equal to positive 2. So this is really just starting to use that information about the range here, okay? So just want to let you guys know that's a kind of important detail in math as well. You have a restricted domain, and then you have your range. And then over here, I'm going to say we start where? Pi over 3, and we end? Yeah, and it's an interval of 1 cycle. So you say, was that why I had to get my restricted domain in pink? Yeah, we're only going to draw 1 cycle of this. But it's periodic, and there's many cycles. Okay, you guys okay with that? And so now you might say, what do I need here? Well, I'm going to go in the middle. Go in the middle. Go in the middle. I need these points here. And this is where you always start, right here, that first middle point, right? So do you guys remember, how do we get that middle value? You're going to use the midpoint. What do you mean by that, right? I can say m is pi over 3 plus what? 7 pi over 3 divided by what? By 2. And notice what this gives you. 8 pi over 3 divided by 2, which is 8 pi over 3 times what? 1/2. What does that give you? Right? Is that 4 pi over 3? So, ladies and gentlemen, this first midpoint here is 4 pi over 3 here. Double check. I know I'm not awake yet, but I think my arithmetic is pretty good on this. All right? Arithmetic here. This is what I'm saying. All of this, every trig student should know. Okay, you guys okay with that? That's the kind of arithmetic you guys want to do. Now, you say, what comes next? Find the midpoint here. And go, well, what is that midpoint? What's the same process? So what's 1 pi over 3 plus 4 pi over 3? 5 pi over 3 divided by 2. So notice what starts to happen. This would be 5 pi over what? 6, yes. So what will start to happen, ladies and gentlemen, with your practice is that you get better and better at doing this arithmetic, okay? Because this will be, remember you multiply fractions horizontally across 5 pi over 6, and there's nothing to simplify. So you get better and better at that. Well, you add them, and then you divide by 2. Like over here. Oh, because I know how to what? Divide a fraction by a whole number, which is to multiply by the what? Reciprocal. And then I know how to multiply fractions. You go, what do you mean, how do you multiply fractions? We multiply this way. Bless you. So that's kind of the essence why I might say, hey, here, let's give you guys some of this arithmetic to do, because why? It's not something that you piecemeal necessarily. What I mean by that is it's something you want to know how to do is arithmetic. It's not going to go away. You know, in fact, I never learned arithmetic until I took all these courses, because you use it everywhere, you know. I even tell that to calculus students. I never learned arithmetic until I took calculus. So that's what I kind of say. Because they're doing I actually have a worksheet, what I call algebra for calculus students. But it's also, you know, there's also arithmetic there in the algebra. Yes. I teach as much classes that they let me. Yeah, calculus 1, calculus 2. Mm-hmm. So what about this one? Could you guys do that in your head? You guys know what I mean? Because sometimes you get so good at this, you can do it in your head. You say, what do you mean I'm doing this in my head? You're doing this whole process in your head. So I would say 4 pi over 3 plus 7 pi over 3 is 11 pi over 3. Is that right? And what do you guys know about 11 pi over 3 divided by 2? It's 11 pi over 3 times 1/2. Is that right? Which gives you? Yeah. And so people start to become what? Good at this kind of arithmetic. That's the idea. And after you do your homework and you go, oh my God, all those questions, you don't want to do them the night before your test. If you do that, it's over, right? You guys want to do that now. And so when you do that arithmetic, you get that good at it. Practice makes what? Perfect. Okay, the difference between people who can do this and people who can't is that word practice. That's all it is. Practice, practice, what? Practice. And that actually works for anything that you want to get good at. It's not just this. Okay, and then what's the last thing you look at again? Do you guys remember? I have to go back and remember, because in all honesty, I don't know what curve this is. This is what? It's not just the sine curve, it's the what? Yeah, negative sine curve. It goes that ghost situation. You say, ghost, yeah, the sine curve would look like this. If you guys recall. Yeah, something like that. Let me see if I can. Oh, I can't move it. I didn't do it continuously. That's how the sine curve kind of would be, right? So what does that negative sign mean? It means we still start here. We still go through this what? These are my intercepts, right? So now what that means is this. The lowest value is at pi over 6. The largest value is where? At 11 pi over 6. So we got to use that framework here, right? And I don't know about you guys. I hate how all this stuff is designed, like phones and iPads, because my own fingers get in the way of everything. I don't know how you guys feel. I hate it. If I'm reading something, if I touch something, why is it that? It messes everything up. And then when I want to touch something to change it, it doesn't even work. You guys notice that? I thought that's an old man thing. I'm like, oh my God, this is just an old guy. You know what I mean? Problem. Anyway, it may not be just an old guy problem. There you guys go. This is what they want you to draw and sketch, right? It's the minus sign, but let's put this in red. Where are the x-intercepts, ladies and gentlemen? An x-intercept is when the y value is 0, right? They're in red there. You're on the x-axis, so it's pi over 3, comma 0. That's 1. 4 pi over 3, comma 0. That is 2. And then it's 7 pi over 3, comma 0. And ladies and gentlemen, here are all your what? Those are the x-intercepts, in case you guys didn't know. It's all these x values here. There it is. And how I like to tell students, even if it's a calculus class or a trig class, I guess, if you're walking, where are you here? Do you guys know? You're in a valley at pi over 6, aren't you? You're in a valley, right? So what's the depth? -2. So this is going to be the minimum altitude That's what they mean. And this is the what? Maximum. So you talk about that, you're at 5 pi over 6, comma, negative 2. The minimum value is what they see here. Okay? And then you say, what was the other one? Oh, 11 pi over 6. So at 11 pi over 6, you're at positive 2. And then, ladies and gentlemen, this is what they're kind of asking for. This is the minimum, and this is the what? Maximum. They want the altitudes. So the reason you sketch that is to find these locations as well. Okay, these points are also important. The minimum value, the maximum value. So you're looking at really all the analysis that you're kind of supposed to know when you're looking at this stuff. And that's the truth. So in other words, when there's an application that has to deal with a sine or cosine curve, those are the real points to care about in terms of the application. And the intercepts, yeah. So that's kind of the deal. And then when you go to a calculus class, you might say, what's the difference between this stuff and a calculus class? Well, they give you a general curve. And you can find minimum, max, and intercepts, blah, blah, blah. And the same kind of physical attributes you care about. So, ladies and gentlemen, all the stuff that we've been working on, in all honesty, you care about investing your time and energy because they're going to help you in the future. You know, that's kind of how wrong button. You got to label those things. And then here, you say, well, what about this? Right? Well, this one's very similar in the sense that it has that what? That minus already. So let's kind of look at all these things here, right? It already has that negative sign. Notice here, my k value is already positive there. So you go, oh, okay. And then I get the phase shift here. I guess it's B, BK, and A. So I just use my definitions. The amplitude is minus absolute value 3, which is positive 3. My period, again, is 2 pi over k. This time k is 4. So what does that mean? Right? That reduces to 2 pi over 2. Is that true? Okay. Now, that interval of one cycle starts at what? Remember this important detail. Whatever comes after this x minus is your phase shift. So your phase shift, again here, this is pi over 2. And maybe you need to write the definition. See, I actually learned these things, these definitions, by writing them down. So you might say, oh, that b value, where do we start? Pi over 2, and then pi over 2 plus my period is another pi over 2. And you go, really? That was fun and easy. What's half a pi plus another half a pi? Isn't that a whole pi? So notice the arithmetic, okay? They have a common denominator, 2, so I just have my numerators. So arithmetic-wise, you might say, was that 2 pi over 2, which is just pi? Yes, that's why we got the pi. Okay? So you start at pi over 2, you end at pi. All right. All right, you guys okay with that? That's why I say maybe it's good to start with that worksheet. So again, now here, and it's not to scale. Y-axis, x-axis. We start here at pi over 2. We'll end at pi. The amplitude is 3 minus 3. So remember, the curve lives between these two values, and the interval of one cycle, which is also a restricted domain, is between these two values. So what's the midpoint between pi over 2 and pi? Do you guys remember? Say pi over 2 plus pi divided by 2. Is that right? So put 2 over 2. Is that right? So, okay. So that looks like it's going to be 3 pi over 2 now divided by 2, or 3 pi over 2 times what? So this will be 3 pi over what? 4, ladies and gentlemen. Good job. Yeah, I'll leave that there. Sorry. Okay, now what should we do? Midpoint between these two? Right? Got to find all those midpoints. So you say, is that pi over 2 plus a 3 pi over 4 divided by 2? Yes. What do you do? 2, 2. Is that right? So what does this give you? 2 pi over 4 plus 3 pi over 4 divided by 2. 5 pi over 4 divided by 2, which will be 5 pi over what? Is that 5 pi over 8? Is that true? You say, why? Because you know the definition of dividing by a whole number with a fraction. You multiply by the reciprocal. So that number here will be 5 pi over 8, ladies and gentlemen. Pretty good? Now we need another midpoint. You say, what's the other midpoint? Erase this. Pi, 3 pi over 4. So we get what? 3 pi over 4 plus pi divided by 2. What do you do with this number here? Isn't that 4 over 4? 7 pi over 4, not 5, 7 pi over 4 divided by 2. What is this going to give us? 7 pi over 8. Outstanding. Absolutely. You say, why, Mr. Judge? Because 7 pi over 4 times 1/2. Remember how you multiply fractions. 7 pi over 8. So there you go. So remember, this is the arithmetic that they're interested in you knowing, because of the fact that it's going to give us the location of everything we are looking for. Okay, go away. See what I did? Touch something I didn't intend to. See what I mean? It's horrible. So what's the curve? Is it cosine or minus cosine? It's minus cosine. Is that right? So we're going back to that ghost idea. So what do you mean? Well, cosine starts here, right? Goes down, lowest. Okay, this is how the cosine curve would really be. Is that right? So what we're going to do is we're going to plot this point down here. And we have the same intercepts. So the cosine curve really looks like this. And there you go. We can get rid of the ghosting. Okay? So this is the curve they want us to look at and consider, and ladies and gentlemen, all the analysis. Okay? So what's the analysis? What's the range? Set of all y such that y is between what? -3, +3. Is that right? That restricted domain, the domain you guys are looking at is, I mean, we could give it either as an interval or set. It's from pi over 2 to 7 pi over 8. X-intercepts happen at x is what? 5 pi over 8. And x is what? 7 pi over 8, ladies and gentlemen. Also, what? Yeah. Domain? Oh, I'm sorry. Pi. I'm looking at that one. Good job. Let's color these things. Maybe that's helpful, right? This is set notation. Okay. The ghost curve didn't start at -3. The ghost curve started, Sarah, at +3. So the ghost curve, remember, this is really the sine curve right here. Starts at positive. Didn't start at negative. It started where? Positive, because that's the cosine curve. Okay, so this is the location of positive cosine, not negative cosine. Now, the y coordinate is at +3, but we don't need that. We want the other one. So, and it's also the x coordinate is pi over 2. So if you said, what's that coordinate? Well, that's x is pi over 2, y is 3. That's for sine. But we have minus sine. Or minus cosine. Sorry, this is for cosine. We have minus cosine here. Okay, so there you go. That's the location. So we kind of don't need that. We need the opposite. And you go, what do you mean the opposite? The reciprocal. So this starting point really is at the x is pi over 2, y is -3. And over here, this is where x is pi, y is -3. And so you might say, why are you actually talking about these? This is where you have a min. This is where you have another min. The minimum value, though, is -3, but it happens at x values. So remember, those are all points in the plane. There's an x coordinate and a y coordinate. Those are all minimum. Where's the maximum? You say, what do you mean by the maximum? Yeah, this is a maximum value. Okay, and we were kind of coloring those blue, I guess. Whatever. Where's the maximum in terms of coordinates? This is what? X is 3 pi over 4, but y is what? +3. So this is the maximum value. When they talk about a maximum value, they mean the number 3, but it happens at 3 pi over 4. So this is why you want to know this is why you're actually finding all of these values. It happens at 3 pi over 4 is not the maximum value of the function, but it happens at that x value. So in some ways, if you say, what if they ask for min and max? Well, minimum is the y value, -3. There's 2. Maximum is the y value, +3. Okay, let me erase this here. So min and max are actually the y values. They happen at a coordinate, though, these important x values, but this is what they mean by the minimum value of sine or cosine in this case. This is what they mean by those min and max. Okay, so let me also do something like this. I'm going to say, by the way, you might say, I seen on my homework some vertical shift. What does vertical shift mean? What does it mean of vertical when they measure your height vertically? That's up and down shift. So do you guys know how that works? Like if I said to you, in general, you might be seeing this stuff in Math 260, right? So I want you guys to note something here. I'm going to give it to you guys as a statement. The graph of f of x plus k is the graph of f of x, comma, but is shifted how? Yeah, it's up or down, right? You go, what do you mean up or down? But it's shifted in one case up and the other case what? Down. We have to know something about k. Okay, what do we know about k? Do you guys know? If k is what? Positive. This was what means k is positive. That number out here is positive. Then that's called an upshift. If k is what? Negative, then that's going to be a what? Downshift. Okay? So I'm going to go back to this last curve. I'm going to copy this. Since we have all the analysis here, only difference is I'm going to change this here. Make it positive. Okay? Then I'm going to say I'm going to add 2. And I apologize. We have to change the letter. Let's change the letter, okay? K is already there, and I'm going to change it. That's the problem with math is we have so many ideas, we run out of what? Letters. Sometimes you have to go to Greek letters. That's why you go to Greek letters. You run out of letters. Okay, I'll call it C. It's an up and down shift. You guys remember seeing this kind of stuff? Up and down shift? Just that added that number. And you see this here? This is the same curve, but I changed it. So I'm going to go back and copy the other one. And I'm going to share with you guys all this information here. It's a very simple idea. You're going to focus now. I don't know what color to use. Darn it. We'll use the brown. You're adding 2. Now remember, this is not the negative, right? This is what? The positive. So there's no need for any ghosting. Is that right? So cosine starts here, goes to the intercept, goes to the lowest value, back to the x-intercept, and then to the largest value here. So I'm going to remind you guys this here, okay? Yeah. So you really know what's supposed to happen, ladies and gentlemen? What does that plus 2 mean? Everything is supposed to be shifted up how many units? Up 2 units. So there's a couple of ways to do this here. I'm going to move this down. Okay? We're supposed to move up 2 units. So what do you think that means? You see this particular point here? I'm going to use this marker. See that point? That's supposed to be up 1, what? 2. Okay? And I really got to apologize to you guys because you want to know what's bothering me about all this? Remember, this is really not to scale. Is that right? Remember how this is not to scale? So I'm going to do this. Focus here. You see this 3? Right? What's 3 plus 2? It's supposed to be 5, right? So what I'm going to say to you guys, that's supposed to be what number? 5. So add 2 to 3 and you get what? 5. Is that right? Add 2 to negative 3, what do you get? So I got negative 1. I'm going to notate this here. Add, what's this location here? Isn't that 0? What happens when I add 2 to that? This point is now 2. So notice what I'm saying here. We can do it this way and say this is now 5. And this point is now what? Negative 1. It's not to scale. Where would 0 be? Somewhere over here? Shouldn't you x-axis? So I can get rid of that line. The only problem is I'm going to have to do what? Copy this point. Pi over what? 2. What's this? 5 pi over 8. 3 pi over 4. 7 pi over 8. And pi. And, I'll get rid of the black. Get rid of that. So what I did was shift everything up 2 units. Every point gets shifted 2 units. I don't want to get rid of that. I want to get rid of that. Get rid of that. So now, ladies and gentlemen, what's this again? That's your max. That's your max. You can't get you're not going to be able to get the x-intercept so easily, so they probably shouldn't ask you these things. But they're there. Okay? So they probably shouldn't ask you really at this point, what's the x-intercept, if you guys want to know the truth. And, they may, and I think, in all honesty, the up and down shifting questions probably should be in some other course later on, like a calculus course, personally. Like when I read this stuff, it doesn't even have that. But anyway, when I read like the state guidelines and blah, 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 they don't have the up shift. Your book does, but state guidelines don't. Anyway, somebody had a question here. Yes. No. You'd actually have to solve a trig equation, which you're not there yet. So here's kind of the moral of the story, right? You say, what do you mean the moral of the story? What really changes? Oops, sorry. I mean, everything changes, but same interval of one cycle, right? You might say, what changes? Well, your range is now between what? -1 and what? 5. Same interval of one cycle domain. Okay, just so you guys know. And the max and min. So they're only going to ask you the max and min questions, really. So I'm not kind of reluctant to, even on my worksheet, to ask vertical shifting, up and down shifting. It's more related. It's more reserved for like calculus 1. Yes. Yeah. Which one? Yeah, I'll give you that as well. I'll talk about that. The maximum value is what now? 5. Is that right? So something like that is kind of okay. You say maximum value is 5, and of course that happens at x is pi over 2 and pi. So here's your maximum value, right? And the minimum value is -1. Happens over here when x is 3 pi over 4. So min is -1. This happens when x is what? The max happens at x is pi over 2, starting point, and x is pi ending point. This happens when x is 3 pi over 4. So you are getting the what? You could get minimum, maximum, but you're not getting the intercepts, just to let you guys know, okay? So like I said, the up and down shifting in my mind is that. Now we have a question. Let's look at this here. So if you said, Mr. Judge, I got really, the book is going to give you a question like this, right? Y equals 2 plus 3 cosine 4x minus, I think that was pi over 2. Yeah. You go, what in the world did the book do? You know what the book did? Again, that author again. That's why I wrote my own worksheet. So in the future, I can get through it, anyway, maybe a little bit more clear in a way. So you see this 2 plus, this is the same as what you did. This is the same as if I say, start with 3 cosine, 4x minus pi over 2, right? Plus the 2. You might say, why is that the same? Because the order in which you add does not matter. So just switch that order. And now it's in the format of a plus C that we gave you guys here. And you go, oh, okay, add, shift it up. Yeah, that's what the author does. It's kind of interesting, but whatever. Say that again? Yeah. Yeah. Yeah, that's what the author did. But when I look at the state guidelines, I'm like, huh. And I did look at the state guidelines. But anyway. But, whatever. Okay, now if I said to you guys, right, just to give you guys another example, to give you y equals sine of, let's try, you guys want to try this out? Pi, I don't think we talked about the factoring, though. No, we didn't. I'm going to say, I'll say pi x plus 2. And then say minus 1. Okay? Just to kind of go through the whole process. So what is A? 1. What is K? Pi. Did they give you a pi? Anybody know something like that? And then this is my C. Is that right? But then focus here. This is probably where sometimes people need the most work. What do you guys think? That's a plus. That's not even a minus, is it? So what does that mean? Yeah, write it as minus a minus. So that means this B value is negative. You are right. Now, B can be negative. Okay? It can be negative. K is the one that can't be negative. So we know with the amplitude. Absolute value 1 is 1. It's not defined that way. Well, let me take it back. What was the real question? No, why is B negative? Oh, this is down C value over here. Let's get that. See this here? What does this mean? It's a downshift of 1. Okay, so we have all the important details here. Period. 2 pi over what? Pi. What's 2 pi over pi? Isn't that 2? Right? Isn't your period 2? Double check. This is still a downshift. Interval of 1 cycle. Write down the definition. B plus P. So what is this? -2. -2 plus what? 2. Start at -2, end at 0. Okay, so here's the deal. You might say, what do I do first? What you do first, ladies and gentlemen, graph it without the shift. So if my amplitude is 1, this is all without the shift. And then it gets even worse. You say, what do you mean even worse? Well, you know what I have to do with this? Yeah, I'm gonna have to try to move this way. And I'm going to move this line this way. Why, ladies and gentlemen? Do you guys know why? Start at -2 and you end where? 0. So you're really starting over here, -2, and you end at 0. Okay, so let me highlight this. -2 to 0. And here you have what? -1 to 1. What's halfway between -2 and 0? Good. Okay, you guys okay with that? What's halfway between -2 and -1? Well, I don't know. I'm going to do my algorithm. Oh, -3/2. You're right. What's halfway between -1 and 0? -1 plus 0 divided by 2. Oh, -1/2. So what I'm really saying is I can get that point, and I can get what? This point, which is -1/2. What curve is this? Sine. So how does that sine curve behave? It always starts where? It starts at the x-intercept, goes up to the maximum value, comes down to the x-intercept, minimum value, and back at the x-intercept. So, notice your arithmetic comes into play. And then we go what? And then you say, okay, Mr. Judge, but what's really happening? We need that -1. We need the downshift of what? 1. So every point on this curve gets shifted down what? So I'm going to have to take 1, -1, 0 -1, -1 -1. Is that right? This is that downshift. So really, the highest value is going to now be what? At 0. And then this point here is going to be what? Well, this one will be -1. This lowest value will be -2. Okay, so we're going to look at this amplitude and the effect. And if it's at 0, by the way, this is your new what? This is the new x-axis. Right? This is where 0 is. And I put that right here. So all of these points now, and what happened? Oh, I think I had erased this. This is where 0 is. -2, -3/2, -1, -1/2. So all of that stuff I had in the past, these points, everything is shifted down. And it shifted down 1 unit. So let's double check. Yeah. Same what? Same restricted domain. Your range is now between 0 and -2. So notice something like this. This location is your max. This location is the what? Min. And that's how you handle a downshift, really, is every point gets shifted down. This is kind of a quick, easy way to do that without having to resketch stuff, in all honesty. But you can resketch it. Sometimes people do. And there you guys go, anyway. Oh, I'm not sure. I think I missed that. Sorry about Sarah. I think I missed that question. Anyway, and then again, remember, this is your what? The x-axis. So I wanted to explain this language here about the up and down shifting, vertical shifting. And, you know, when you learn that, some of that shifting in Math 260, the idea is in 261, when they give you a curve like that, you know what it looks like. But anyway. So I do think up and down shift belongs in a Calculus 1 course, not in a 241 course, personally. And when I read the state course outline of record, I think that's there as well. So anyway, so I think I'm going to adjust my sheets too, but I'm not sure. Yes. If the homework asks for what? It depends. What do you mean by it? I don't think they'll ask you for the x-axis. You know, there is an x-axis. What I'm saying, you might mean x-intercept. X-intercept. I think in this case, it's easy to find because it's on the curve. But I don't think generally they're going to ask. They should ask you that on a vertical shift. So I even have to fix my stuff because that requires you having knowledge of solving trig equations, and you don't yet. That's why I say it probably is a Calculus 1-ish question. So I'll even adjust my worksheet. So if you said, how does this really work in Mr. Judge's head? Well, I'll adjust my worksheet. So you know I can pass that information on to you that will be consistent with our state guidelines. Anyway, I got to pass back these exams. So I'll see you guys tomorrow. If you're in class, we're going to pass back your exam. And if you're at home, take care and stay safe.